Okay, Assalamu alaikum everyone. This is Syed Jafar Ali, lecturer in King Khalid University, College of Computer Science in Computer Engineering Department. My background is I am Masters in Power Electronics from Electrical and Electronics Engineering Department. So I have 20 years of teaching experience. Today I am basically from India. Now we will start our training session. It is on Arduino and electronic circuits online building. So this electronic circuits, we know day-to-day life. That's we have many components, many devices, and I am gathering all the information, and I want you to share regarding how to build an electronic circuit online based on different conditions like building blocks or programming. And my motto is to make you know about Arduino, its features, and how to connect different electronic components, devices with Arduino in day-to-day life. So I will go slowly. So if I'm going fast, you can stop and you can ask doubts in between. Basically, I'm using a online platform, Tinkercad. So this I will going to there in the browser. So here I'm using this tinkercad.com online platform, so that which is very easy to build any electronic circuit, and it has many other features like AutoCAD, building any designs of different robotics, everything we can do here. So I will start with basically how to sign in. Here you can sign in with a Google account, or you can create your own account, Tinkercad account. But I will join with my some Google account. So we'll start creating a new account in Tinkercad. See, it's logging with a new account in tinkercad.com. Here we have 3D design, circuits, code blocks, sessions. My motto is to make you knowledgeable on circuits, which is useful for any projects, mini projects or major projects. And you can play also if you are habituated how to use these components. So now my today's session, what I am teaching, I will show here. So this is my topics which I am going to teach today. That is introduction to Tinkercad website and its account creation, overview of tools used in Tinkercad, introduction to Arduino structure, basic LED circuit for real life applications, RGB and LED circuit preparation, LED using digital output of Arduino using blocks, LED using analog output of Arduino using block, LED using analog output with loops in Arduino using block, traffic control circuit building using blocks, servo motor circuit building using blocks, gas sensor circuit building using blocks, ultrasonic distance sensor building using blocks, temperature sensor circuit building using blocks, temperature sensor with RGB LED building using blocks. Another block is servo motor and LED as output with potentiometer and temperature sensor input building using blocks. Up to 15 we are using block sets to build a circuit. Now from 16th and to 18 temperature sensor connections and programming. So here we will start programming. LCD 16:2 display connection and programming. Now last one is temperature sensor with LCD connection and programming. So here we have plenty of time. 5 hours time is there. Slowly one by one we will start. We will proceed for different circuits. Now here I will start with a creating new circuit, and I will show there different tools inside that one. Just we have to go to the tinkercad.com and create one account and log in that and use here circuits link, and here it will come a basic one. Now create a new circuit, you can click on it. Now it will open a window. Here, this is the space where we can build our own circuit. Now on the right side, you can see different components. On the right side on the top, basic components it's showing. For basic, you can share resistor, LED, push button, potentiometer, a capacitor, battery, different types of battery, and a breadboard. Here Arduino Uno R3. Different components are there like micro servo, LED, RGB. If you want all, then you can have browse from all. Then all components, what the capability it has, it is showing here in all components. These all are drag and drop components. You can just drag and drop there and connect it. So step by step I will show how to connect and how to execute and how to build a circuit. These are the components what I am showing to you. So if you come to the on the top where there is a code, in this code it is not showing now. When you use Arduino Uno, then here it will show the different parameters, how can we program or we can use the block sets. Now after compiling the block sets or program, we can start simulation. And this export is to export the circuit in different fashion, or you can download the program from here and you can debug everything. All options are there. Step by step we'll go. Now we close the code. Now what is the different drag drop? I will start with a small one. This is called basic LED circuit. I will take. You can rename here basic LED circuit. I am renaming the file with the basic LED circuit. Now if you see the basics, then you have an LED here. Now here LED, if you place, just drag and drop, it's very easy to use. Here we can have name LED. You can have different colors of LED: green, yellow, orange, blue, red, white. Okay, I will use red only. You can zoom it. Just you can zoom the components. Now let us take, I am adding a 9 volts battery. Just click and drag here and you keep it here. Now let us take, I connect this here because you can see easily from your window. So I zoomed in bigger size. Now here it is showing the components. Say here cathode and here it is anode. Generally how to in physical component, how to identify the positive and negative of a LED is the length of the terminal. These two hard terminals are there. If it is big terminal is, that is called anode. That's why small tilt it is showing here. But in physical, it is the positive terminal which the length of the terminal is bigger one. Means the length is high, that is a positive. Whose length is small, that is a cathode. That is one phenomena. Now this is 9 volts battery. We have positive terminal and negative terminal here. It's showing directly. Now here I want to show to connect this 9 volts battery to the LED. Let's connect directly, then we'll see what's happening. This is positive. I'll just click on the positive terminal. If I move it and again click it, you can bend that like this. Again you click, you can bend like this. Starting will go slowly, don't worry. Again click, you'll go here. So this is anode, means this is a positive. Just place here. So this is a wire which we connected from positive terminal of the 9 volts battery to the anode, that is positive, we call for the LED. Now here color of the wire, we can choose any color. Generally, positive terminal will be red. Now type normal. This is anything you can use. Normal type you can use. Now this is a red terminal which I connected to the LED. Now same, go to the negative. Click here. Now go up. Click here. Now here. Now generally we have black. Now click here. So one simple circuit is ready. We will have big circuits, don't worry, in later sessions, in later time. Now if I start simulation, what's happening? In generally, if you connect this battery in physical life with a LED with 9 volts battery, you will lose one LED, I can say. How I am showing. See here. See, I started simulation and it is showing that this LED is burned out. But this is a simulation base. So here we can stop the simulation. The same LED I can use for with the different voltages and with the different constraints. Okay. So now see here what it is showing here. Current through the LED is 915 milliamperes, while absolute maximum is 20 milliamperes. So the LED can handle only 20 milliamps, means 0.02 amps. But it is 915 milliamps, means 0.9 amps it is taking. That's why it surely burn. In physical life, the LED is we cannot use later. Once it is burned, we have to throw it and we have to purchase new one. There is a beauty here is we can utilize many times. We can have many experiments and we can test many times. So I will stop the simulation so that I can limit this current. The 915 milliamps current it is there, that I have to limit to the 20 milliamps, below the 20 milliamps. So what I need for that, I stop the simulation. For that I need a resistor. So resistor basic property to limit the current. Okay, so just drag this resistor here. Okay, I can rotate this resistor. Now the another beauty of resistor is here in the resistor you can have name R1, no problem. Now here how much you want to put, you can put. This is say ohms, kilo ohms, mega ohms, giga ohms, same milli ohms, micro, nano, pico ohms. So it predefined values are predefined values we can have. That is resistance. If I want only 100 ohms, let us take. We will see. Then automatically the color is changing. I am not teaching here what is the color code and how to calculate that one. What is a multiplier? How we know the value of the resistor by seeing its colors on the resistor. That is a different topic. So here, when I change the resistance value, the colors automatically changing on the resistor. So if I want only 100 ohms, just change to ohms here. I use 100. So here the color calculation will be there. You can have in other subjects how to calculate the resistance value. Okay, now what I am doing, just I can connect here. Okay, remove this. Now I can rotate this. Okay, now I will place this resistance. Now I will connect this to, see, I can readjust anyhow. So red, again this is okay. Now see, there is a battery and there is a LED and we got a resistance. Now how much resistance? Just click, you can know 100 ohms. Now let us see, this 100 ohms is enough for limiting that 900 milliamps current. Just start the simulation. Okay, but it is showing some warning. What is warning? It is showing that 20 milliamps is the capability of the LED, but now it is flowing 65 milliamps. It may burn if it is more than that. So by this also you can understand, we can slowly increase our resistance value. So from 900 milliamps to we drop to 65. So another 50 ohms if I add, I think it is better. We have 150 and let us see what's happening. Now start simulation. Still 45. So we can have 220 ohms. Let us take 250 will take. So like that, this is the fashion how we will proceed for our simulation again. So 27, see, we limited the current from 44 milliamps to 27, 50% we limit. So another, we just double the resistance value, maybe it will save now. Good, alhamdulillah. So we have a better appearance now. Now LED is working with a resistance value of 500 ohms. Step by step, if you want to see, you can see by the exact value where it is getting 20 milliamps. That's later in your simulation you can do it. So this is the basic circuit I am showing here. Now let's go for the another one. There is LED with RGB light. Another example with basic components. Next we will go to the Arduino. Now just delete this 9 volts battery. Just you can select and delete button you have on the keyboard, you can delete it. Just it's simple. Now I can delete this. Now there is a RGB we call, yeah, this is LED RGB. What is the function of this RGB? By inbuilt, it has 3 different light colors, that is red, green and blue. But here 1 2 3 4 connections are there. So we need for any component 2 minimum connections we need, that is positive and negative, or anode or cathode. Like this, it has 1 common cathode and 3 different color LED connections. That is for red, this is the left side, complete left side, it is for red. And after the third one, that is called blue, and the right one is green. So its actually name is red, green, blue, but the components connections are with RBG, you can say RBG, red, blue, green. But it's by default name, it came popular with the name of RGB, red, green, blue. But remember that blue and green are reverse in actual connection. So now what I need is, next let us take, I will not take 9 volts battery. Now a different type of battery will connect. So join, let's take 3 volts battery. Just take it. Now connect this here. Okay, LED will go up here and RGB here. Okay, now for this RGB connection, at a time all connections with positive it's giving is not good, because I have to show different colors of the light in different time. Means I want to on only red light, I want to on only green light, I want to on only blue light. How to do that one? For that, what I need, 1 2 3, we need 3 switches, so that at a time only one light can be, one color of the LED can be glowed. So for that I have here switch. I can take from all components, go to the all components, one multi-purpose switch is there, go to down, yeah, DIP switch, SPST, single pole single throw switch with 4-in-1. 4-in-1 we can share, just keep it here. Yeah, now I can connect easily. Here we have 1A, 1B, means this first switch, second switch, third switch, and fourth switch, all in one. And at a time we can on and off, no problem. While simulation, we can on and off. Now by default, just only connection we have to make without simulation. So what are the components I need here? One 3 volts battery, one LED, one RGB LED, and one resistance. I will tell why the resistance is required later, because step by step, if a connection is made, then we can know easily. So this is positive, I can have it from here, then come here, go here. Now connect, sorry, 3, because we have only 3 connections. So you can connect here, different colors you can use. I will use orange. Same thing, I can use another connection. Here I am not coming to the breadboard, because that explanation I will do for the further circuits. Here simply I'm showing how directly also we can go. See, very easy fashion. This Tinkercad uh, online platform is very easy to use. Now another connection, if I take, okay, later we'll change the color, don't worry. Now connect this, now arrange this properly for good look. Now they can rotate this, no problem. Okay, now let's take different color of this light. Blue we can have, or GB, yeah, this let us take gray, red. This green, let us take RGB, like RGB, but here the connections I will show how the light is glowing. Now here negative connection is there. We can have one for the cathode of the one LED. Directly I'm connecting, don't worry. Now this should be black. Now another, because we need another black, that is negative terminal. Okay, from the top I will take from here. This is the cathode, be careful. This is the cathode, and okay, no problem. You can play as you like, because all this board and this simulation is for you. It's black now. Okay, so this is, I have negative connections. I given to one for the normal LED with another negative connection I given to the RGB LED to the cathode. Now this DIP four-way switch, I am connecting the output from the switch. One is to the red. I can change to the red color. Now second is to blue. So I can have blue, no problem. And green. I can have, sorry, green. Okay, it's default green. Now one is missing, that is called this connection anode. So for that I need here. Okay. If I connect directly, I'm showing here. Another red or any other color you can share. Purple. Okay, purple you can use. Okay. Now our circuit is finished. This resistance later I will discuss. Now if you start simulation, now what you are showing here, the LED, the normal LED directly connected to the 3 volts battery. How much it is? It is 61 milliamps. It is taking only 20 milliamps is a capability. So for that we need a resistance in series with that. Okay. Before going to that, now we'll just stop the simulation and remove this. Now connect. Now from here to here. Now there won't be any problem. Purple and purple. Now start simulation, please. See, but the brightness of LED is very less compared to the previous one. So for that, what is the problem here? It is the resistance value to 500 ohms. It is very high, you can say, not low. So I will change this resistance value to, let us take 200. Now see that. Now I will change resistance value to 20. Now the problem is here, it is showing the 28 milliamps. Means resistance we can have slight increase from 20. So we'll have 30. No, we'll must have 40. Okay. So let's try 35. No. So we need 40 ohms. Okay, there won't be any wrong. So this is a brighter, which is compared to the previous one, more brighter this LED. Now this is the basic one. Now we'll see this RGB. Now this RGB light is, if you switch on the first one, just check, it is gone. Why? Because it is directly connected. So for that, what we need, same principle for normal LED, how we kept this resistance, for this also we have to keep the resistance. Okay, now let us see all others. If you on this, all, if you on, all lights are burn, all LEDs are burn. Okay, so for that, what we need, another resistance we need in the circuit. As per this single LED red color, what we did in the anode, that is in the positive line, we kept a resistance, not in the negative line, right? For that RGB, for the RGB, what same fashion, if you think in the same fashion like this LED, for the RGB also, what we need a resistance in the red wire, that is red color connection, blue color connection, and a green color connection, right? Here we need three resistances. Now I will tell you the optimal way. The optimal way is we can use only one resistance, not in these three connections, that is red, blue, or green. We directly connect in the black, because at a time we are on one switch here, or if you on all switches, the complete circuit is one, that is from positive to the LED, from the LED to the negative, negative to the battery. So the resistance always come in picture in the circuit, not in different way. So now just remove this black, or first you take the resistance so that it is easy. Now take it and rotate. Okay, I will keep in here. Now one good thing is we can remove connection like this, or you can delete complete the wire. Sorry, see, you can remove the connection. No, for one step we can remove it, not from step by step we cannot come back. So my advice, first you just remove the complete wire. Now take from here, take it here. Now connect it here. Now this, take it here. Now here to here. Now take the black. Now see here, black. Now let us start simulation. Start simulation. Okay, LED already is glowing, battery. Now I will start this one, red color. See, red color with a series like a normal LED. Now if you switch off and again start this, blue. Now this is called green. So like this we have to connect one by one the different components to the different devices, and we can have the output by simulating it. Now if you go to the code block, there is empty, because there is no blocks and there is no programming needed for this direct connection. Programming and code needed with an Arduino. So that will our next topic. We will go to the Arduino. Now you just understand here, only one switch at a time on. So that is, it is green, and it is off, and it is blue, and it is off, it is red. Now if you on another switch, what is the connection? It is a combination of red and blue. Now if you on this, it is a combination of all three. It's a color combinations, and it's a material, what the LED is made up of, how the light is glowing. Based on that, the connection and the color is coming out. So don't worry about that. So this circuit name I can change, RGB. Okay. Now change, stop simulation. Now this week I want to save, just just change the name and finish the circuit and check the simulation by starting the simulation and check the performance and stop the simulation, and you can go back to the main website Tinkercad. Because if you draw another circuit by removing this, it is not saved. So if for future reference you want to save the circuit, you have to go back and we have to build a new circuit. So go back from the left corner top, just click it, then it will open to the main window. That is, see already so our one fault here came out. The first one, basic LED, that is with 9 volts battery, is gone because I overrated on it. So don't do this one. So every time when you finish the circuit, just change the name, that is a file name, and go back to the Tinkercad main window by pressing here, by clicking this one, Tinkercad. Okay, now again I want to create new circuit. Just create a new circuit, it will open fresh window. Now what is our next topic is, okay, overview tools. Okay, introduction, Arduino introduction we left out. Okay, just we'll go for Arduino introduction. First I will show how the Arduino is like this. So this is your Arduino, the structure of it, and the what are the uses and what are the different components. One video is there, just watch the video. I'm just playing the video for you, then we'll come back to the Tinkercad for the simulation. Just watch this video.
If you like tinkering with electronics, but time constraints and a lack of knowledge are preventing you from making a start, then Arduino is the solution. So what is Arduino? Arduino is a microcontroller-based open-source electronic prototyping board, which can be programmed with an easy-to-use Arduino IDE. Arduino consists of both a physical programmable circuit board and a piece of software. The Arduino IDE uses a simplified version of C++, making it easier to learn. The Arduino platform has become quite popular with people just starting out with electronics, and for good reason. The Uno is one of the more popular boards in the Arduino family and a great choice for beginners. In this video, we'll talk about what's on it and what it can do. The major components of the Arduino Uno board are the following: USB connector, power port, microcontroller, analog input pins, digital pins, reset switch, crystal oscillator, USB interface chip, TX/RX LEDs. Now let's take a closer look at each component. The first component is the USB connector. This is a printer USB port used to load a program from the Arduino IDE onto the Arduino board. This board can also be powered through this port. The next component is power port. The Arduino board can be powered through an AC to DC adapter or a battery. The power source can be connected by plugging in a 2.1mm center positive plug into the power jack of the board. The Arduino Uno board operates at a voltage of 5 volts, but it can withstand a maximum voltage of 20 volts. If the board is supplied with a higher voltage, there is a voltage regulator. It sits between the power port and the USB connector that protects the board from burning out. Now let's take a look at a very important component: microcontroller. It is the most prominently visible black rectangular chip with 28 pins. Think of it as the brains of your Arduino. The microcontroller used on the Uno board is Atmega 328P by Atmel, a major microcontroller manufacturer. Atmega 328P has the following components in it: flash memory of 32 KB. The program loaded from the Arduino IDE is stored here. RAM of 2 KB. This is runtime memory. CPU. It controls everything that goes on within the device. It fetches the program instructions from flash memory and runs it with the help of RAM. Electrically erasable programmable read-only memory, EEPROM, of 1 KB. This is a type of non-volatile memory and it keeps the data even after device restart and reset. AtMega 328P is pre-programmed with bootloader. This allows you to directly upload a new Arduino program into the device without using any external hardware programmer, making the Arduino Uno board easy to use. Next is analog input pins. The Arduino Uno board has 6 analog input pins, labeled analog 0 to 5. These pins can read the signal from an analog sensor, such as a temperature sensor, and convert it into a digital value for system understanding. These pins just measure voltage and not the current because they have very high internal resistance. Hence, only a small amount of current flows through these pins. Although these pins are labeled analog and are analog input by default, these pins can also be used for digital input or output. Now let's look at digital pins. You can find these pins labeled digital 0 to 13. These pins can be used as either input or output pins. When used as output, these pins act as a power supply source for the components connected to it, and when used as input pins, they read the signals from the component connected to them. When digital pins are used as output pins, they supply 40 milliamps of current at 5 volts, which is more than enough to light an LED. Some of the digital pins are labeled with the tilde symbol next to the pin numbers 3, 5, 6, 9, 10, and 11. These pins act as normal digital pins but can also be used for pulse width modulation, PWM, which simulates analog output, such as fading an LED in and out. Next is reset switch. When this switch is clicked, it sends a logical pulse to the reset pin of the microcontroller, and now runs the program again from the start. This can be very useful if your code doesn't repeat and you want to test it multiple times. Next is the crystal oscillator. This is a quartz crystal oscillator which ticks 16 million times a second. On each tick, the microcontroller performs one operation, for example, addition, subtraction, etc. Now we'll look at the USB interface chip. Think of this as a signal translator. It converts signals in the USB level to a level that an Arduino Uno board understands. The last one is the TX-RX indicator. TX stands for transmit and RX for receive. These are indicator LEDs which blink whether the Uno board is transmitting or receiving data. Now that you've explored the Arduino Uno board, you have started your journey toward building your first Internet of Things prototype. How to get started. Buy your Arduino. Install Arduino IDE. Install the libraries. Get familiar with the IDE and the programming language by practicing. Now, bring your ideas to life.
Okay, welcome back. So now you know the small concept of the Arduino by step in different circuits. You can have more exposure to this Arduino connections and its programming, its building. So the next topic is okay, what's going on? Okay, RGB LED circuit preparation is finished. Okay, LED using digital output of Arduino using blocks. Okay, now going to the here. Yes, what is coming? Now come back to this Tinkercad. Here we grabbed one Arduino here. Now I will just rename this one file with LED digital output. LED digital output. Just rename that so that it will be saved properly and we can reuse this file. Now if I can zoom this one so that you can see properly the Arduino structure, our different pins, the digital pins and unlock pins, the power, everything. Step by step we'll study in different applications. Now what we need? A LED. Now the LED, we have digital pin 13 is directly connected to the LED. It can be glown directly. No need of any basic programming. Just small 1 or 2 blocks. If you connect, you can connect. See here, just brought the LED here, so that I will put on the top. Yeah, so red. Okay, no problem. Now connect this cathode to ground. Very good. Now same principle. If you connect LED directly to that 13 pin, what happens? Okay, we'll see, because it's not a physical life. It's just simulation. We are not losing anything here, and we are not wasting our money also. Just connect directly. Now let us see. Red. Okay. Now I will. Sorry. Okay, now if you move this cursor outside the circuit diagram, then you can move the complete circuit at a time. If you move the cursor on each part of the circuit and some part of the circuit, then that part only moved. So I want to move this complete circuit to the left side, so that I can have one code here. So you have to move the cursor outside the boundary of the circuit. So now click and move, click and move. So I am moving like this. Click. Now check the code. Okay, yeah, this is the code. Now previously without the Arduino, this code was space was empty and it was showing code cannot be displayed like that. Okay, now here with Arduino, the code blocks will come, and if you want blocks and text, see many big one is there here. All the controls are there which we can build in this space, where default set built LED, wait, set built LED, all some blocks are already by default connected. We can reuse or we can delete and we can use new one. But on the right side, there is a program, there is a code. If you want to type purely program itself, not using the blocks, then you have to go with the text, just only text. It will ask, because it is not a reversible process. Means if you are using the text that is for the program, you are writing the program, then you cannot come back to the blocks. But if you are using the blocks, the program can be displayed, but not the vice versa. See here, I'm showing the example. See, are you sure? It's asking, press continue. See, only it is showing the program. See, you can type the program here now, and the blocks are not coming. Now if you go on to the blocks, see, he's asking directly, the program will go, the whatever the program you type, that will not reflect that it is saying. So continue. Now it is showing the controls and the blocks. If you want both, you have to use the blocks and programs. For that I will show here. So if I remove this complete blocks and I put the bin here, there is a bin here. Yeah, see, everything is gone. The all program is gone. Now these are the output and these are the input controls. Read digital pin, read analog pin, read degrees of servo pin, number of serial characters available, read from serial, read ultrasonic distance sensor, read temperature sensor. By default they build blocks and they kept here, and we have to immediately we can use it in input. Now output, these many are there. Set built-in LED, high or low. High means glow, low means do not glow, like that. High means 1 or low means 0. Also we can say high means 5 volts, low means 0 volts. These are the 3 notations I am telling to you. Now set pin, here different pins will be there. How many pins are there? Step by step we'll study that one. Just I'm reading out what are the blocks we have. Set pin, rotate servo pin, play speaker, turn off speaker, print serial monitor, set RGB. All we'll study one by one. And this is notation. Notations is like a comments where our blocks are used. We can type our comments how we are using those blocks. That's it, not a big deal, that one. Like in the program we used to write here, delay little bit to improve the simulation, like that, the comment, which helps the user to understand the program. Here I can say which helps the user to understand the blocks. by the notations. Okay, now controls, we have different controls. Means loops we can say are wait, repeat, or repeat with while, or repeat with until. We have if condition and if else condition, count like a for loop we can have up to, or up means going up or going down, means 1 0 to some x number up, down means from x number to 0. That is the loop, it is count loop. Now we have math controls here. Different controls are here. Pick random and either or conditions. Mapping is there. Constraint is there. High or low you want to set, you can set is. These equations you can write with this above two. In the conditions, why you can use this one for the conditions. Just for equations we can use this one. And for pick random numbers you can use this one. Okay, so step by step we'll study those. Now variable means in some programs or some code we need to create one variable so that we can have some equations and we can set some value in that variable. We can use those variables for the equations. Okay, temperature sensor, we have some variables we need, many are there. We'll study that one. Now I will take only blocks now. I will not take the program. Once I finish the blocks building, I will show the program also. Don't worry. Just go to the blocks. Now I connected this LED, right, with the ground and pin number 13. So already I told you in the video that we have 0 to 13 digital output pin, right? Digital output pin. And in between, we have this pin number 3, pin number 5, pin number 6, pin number 9, 10, 11. Some tilt sign is there. If you see, zoom it, what it is showing? It is sinusoidal sine wave like symbol it is showing. So it is called analog pin. In the next circuit, we'll study what is analog pin. First, we'll see the output of the digital pin. Now, in this, what we need, we set a LED. Okay, so in this output, because we need output, not we are not taking the reading to the Arduino. We are giving the power to the LED. So that is called output, not input. Okay, so output. See, set in the controls output, we have different types of blocks. Use set built-in LED 2. So grab this, click here and grab this here and place here. Now sit built-in LED. See here, be careful. Built-in LED, I told you this 13, number 13, only the built-in LED. Otherwise, if you are keeping the connection other than the 13, like 12, 11, 10, anyone, if you are connecting, you have to use set pin, this one. So in this, all are there from 0 to 13 and A0, all pins numbers are there here, 0 to all pin numbers. You can use any one. So other than 13, if you are using, you have to use set pin, this block. If you're using 13 as output for the LED, you can use set built-in LED 2. Okay, so I use here. Now I want to add some delay. What is a delay? But from the controls. So delay means I want the LED to glow for some time and I want to off the LED for some time. So here just I grab this wait block and I added here like this. Just see, I added down class. Now here you can have this control, wait control in seconds or milliseconds. If it is in milliseconds, you know what to write here, 1000 for 1 second. It's up to you how much you want to put it. So I will put for seconds. Let us take 2 seconds, no problem. Okay, now I can start the simulation. Just start the simulation directly, because what I kept, this is a complete loop one. It doesn't mean that set LED to high, it will glow after 2 seconds, it will stop and no output later. No, it's not like that. It is this block set. The window is nothing but default loop, means continuously it will run continuously till the Arduino has the power. We give the power supply to the Arduino, means this, if you start the simulation till you remove the power, or if you have some other code here, till that time the program will, the block set will continuously rotate, continuously running. So start simulation. Yeah, see, LED is glowing for 2 seconds. then again it will go, again it will go. It's not stopping it. So it is no use of putting the wait signal here. So if you put another block here to stop the LED, then we can understand how much time it is on, how much time it is on. Okay, that will go later in 10 seconds. Now see here, what is the problem here on the LED? It's showing warning. It is giving 52 milliamperes. See the same problem what we face for the direct battery. Now it is 20 milliamperes we need, it is 52 milliamperes. So stop the simulation. What we need? We need a resistor. Okay, I can have the resistor here. Just remove this. Okay, you can put like this. Directly you can connect, and from 13 to here. Now put the red one. As little bit slow I am going because of the starting of these simulations, because you have to understand correctly. Now start the simulation, see the code. Now the brightness is very low, very poor. So why? Because it is in 1 kilo ohm. It's taking all the voltage. Generally, what is the output between 13 to ground? It is generally 5 volts. So LED for high, for full brightness, LED may require 2 volts, 1.5 to 2 volts. So for that we have to limit the resistance value so that the LED can get the more voltage. So just take 150 ohms. Now see, brightness is increased, right? Now if I take 100 ohms, okay, this is also good because we are giving 5 volts. So next, if you want to decrease some more, 50 ohms, let us take. No, we have some warning, 26 milliamperes. So we can have 75 ohms. Not enough. So take 100, no problem. So this is the digital output, but my explanation is not over because we just switch on the LED. We are not switching off, or we are not having one loop. So for that, just stop the simulation. I need output same like the previous one, set LED built in LED to high. I need another one. I just place here and place it low. Now here again, low means here we have to switch off. Low means 0 volts. Low means 0. Now we will wait another delay. Let us take 1 second, no problem. Now see the output. The circuit is, or this code or everything is by default, it is saved. See, for 2 seconds it is on, and for 1 second it is off. Means after on 2 seconds it is off. So I will decrease this and I will increase this one. So now check. See, it's blinking. The LED is blinking. So means the, now I will, oh, it is a millisecond. Sorry. Okay, now start. Yeah. So this is for 1 second it is on, but for 2 seconds it is off. You can increase and decrease the time period, no problem. So previously, like it is 2 seconds more on time and less off time. So for 2 seconds, see the time simulation here. Time period of the simulation is showing 2 seconds on, 1 second off, again 2 seconds on, again 1 second off. So you can cross verify the output also. It is correctly working or not by simulator time. You can check. So this is your basic LED digital output. Okay. Now we have another 10 minutes. In this, we will see LED digital, not digital, analog output. Then we'll go for the Maghrib Salah. Okay. So just I finished. Okay. Now one thing I want to show. This is blocks. Now check the program. That it will come. See what we are doing. Void setup. We are just pin mode 13 means we have in the main program we have to write where the output is going. That is, this is the default functions where we have to use statements. That is pin mode. Spelling is very important. M is capital here. Same only we have to use. You cannot use as your own because these are predefined one. So pin mode where we are giving the output on the 13th pin. What we are giving? We are giving output. If you are taking input from outside, then you have to write here input, input. Now in the loop we are writing something on the 13th pin. So digital write means digitally we are giving some value on pin number 13, that is high, means we are giving 5 volts. Now how much your delay? I told you 2 seconds. Here 2000, always program is in milliseconds. In the program it is in millisecond, so it is 2000 means 2 seconds. Now again digital write 13 low. Each block it is having one statement here, program statement. Digital write on the same 13th pin we are giving low, means no voltage, means the light has to be off. For delay 1 second, that is 1000 milliseconds. Okay. So this is already saved. In later if you have any questions, I can open this circuit and again I can answer your doubts. Now go back to here. I think it is clear to you. See, all 2 circuits are saved here. Okay, we have another new one, create new circuit. So now I'll put the new circuit, LED analog output. So the name is LED and analog output. Okay, now take the Arduino Uno, drag it here. We'll go fast, no problem. Just we know how to drag and drop. Take LED here. I will make zoom. Okay, now take the resistor, no problem. Now you see here, which is the analog. I already told you. Analog outputs are where the beside the pin number there is a sinusoidal symbol is there, tilt symbol what you call, or sinusoidal symbol, like 11, 10, 9, 6, 5, 3. These 3, 5, 6, 9, 10, 11 are the analog output. What is the function? I will tell. So here, yes, you connect it to, this is output, red. This is given to the positive or anode of the LED, and this is given to the ground, black. Okay, so so that I can zoom it further, you can understand easily, and I can move here. Okay, so now coming to the code. Circuit is simple, code is very important. Now I can have this code further here. Okay, now by default what we have, the blocks I can put in the garbage, delete. Now step by step we'll go. See here, we cannot use set built-in LED pin, right? Because we're using pin number 11, not 13. Okay, use set pin here, high. Which is the pin number we are using? We have to define his here. So 11, pin number 11. Okay, by inbuilt it is a analog. Here only we have to mention the pin number, whether it is analog or digital, the board knows and background program knows. Now we are setting set pin 11. Now one thing we missed, the value of the resistance. It should be what I mentioned, 100 ohms, right? 100 ohms. Okay, let's start code. Just one by one, step by step also we can see the result. That is the beauty of this Tinkercad. Step by step, see, it is a loop. So directly it is on with set pin 11 high, right? But this is for digital. This is for digital. That's why I'm showing you. Okay, it can be used for digital output or analog output. Both I am showing. This is for digital. This is high or low. So it will not stop. It will stop. But what is analog? So for that we have a set pin here. Okay, just I will remove this. Just compare this one. What is the difference? Here only high and low is there in set pin, but here here also in set pin 3, 5, 6, 9, 10, 11. These are the analog pins. That's why separate block is there. So here there is a oval shape box where we can enter some numeric value. Now explain the analog. So here in analog pins, Arduino has the function that we from 0 to 255 can be typed in this box based upon the voltage will change 0 to 255. The number 0, in between 0 to 255, if we change, the voltage will change according to the number on analog output. Okay, I will show that one how it is. Now see, I will remove this one. You understand this already. Now it is 0. Okay, no problem. We will come from the higher. So I told 255. Okay, I typed here. Now start simulation. See, writing. Now if I use 100, start simulation. What do you observe? You observe the brightness of the LED, the glow is less. If you use 255, very brighter, means maximum brightness will come with number 255. Just remember this. Okay, you can get the maximum brightness with 255 and minimum brightness, or we can say off it 0. So for that I have one program. I can add in fast in nature the blocks. I will add it. You can see the beauty of the analog output. Okay, okay, set pin to 0. Now we can have one delay. Wait, sorry, drag it and put it here. Wait for 1 second and output. Okay, now for copying, because every time one adding is not good, so we can just copy, because every time if we add, we have to set the pin number, we have to set to the some value, again we have to add the weight, and we have to change the weight seconds. So for that, if you move the cursor on the down, the beneath the block, and right click, you can duplicate only that block only. If you go and put your cursor on the top west, or on the top of the or highest position of the block, then you can copy the complete blocks of that setup. So duplicate, you can have, see, you can duplicate all these two. If you have 4, you can have duplicate all 4. So like that. So I'll put it here. Now next, duplicate. See, I got 4 now. So like this, fast also you can go. I need more. 448. Good. Okay, later we'll say. Now, so set pin 11, all pin 11. Otherwise, if we add one by one from the output, we have to set the pin every time. We have to set the wait signal. It's wasting time. So set pin 11 to 0, and another 1 second I will wait, and set pin to, let us take 50, and set pin for the another 1 second wait, another is 100. Next wait another 1 second and 150, and wait and another 200. Now again wait, and maximum I will go now 255. Okay, okay, this is one step. What we call, for every 1 second we are increasing the brightness to some value. The exact calculation you can have with mapping. If it is 255 is highest brightness, then what is the percentage, you can have by calculation, no problem. That is not our goal. Now again 255, wait 1 second, I will go back down, so 200. Now 150. Okay, now I will take from here, copy, no, here, duplicate, only 4 I need. Okay, 200, 255, 200, now 150, this is 100, and this is 50. Okay, see the blocks, I will minimize it. Yeah, so what I'm doing here, to the pin 11, all same in pin 11, output we are giving with 0 to 255 range. Every time I'm adding 50. So from 0, 50, 100, again 50, 150, again 50, 200, again 50, 250. But it is maximum value I gave 255, and decreasing down means minus 50, 255, 200, again minus 50, 150, 100, and 50. By default, if you rotate, it will come to 0 here. Okay, because it is a loop, continuous loop, it is indefinite loop, we can say. Now start this. Okay, see here, see here, see here. Okay, I'm zoomed it here. You can observe the step by step. For every second it is, you can decrease or increase the time. See how is the beauty it is. What you are observing, step by step, for every second the brightness of the LED is increasing. to the maximum value, and for next seconds, for every second, the brightness is decreasing to 0. Enjoyed? So this is the second one, LED analog output. So you can have, yes, LED analog output. Up to here it is finished. I have strikeouts. Okay. Now we can go for with loops. Okay, later we'll go for the loops. I think we need some break. Okay, I have another 2 minutes. I will show here. Stop the simulation. I want to show you a program. So go to the program, but it build automatically when you use the block. It build the program. See here. What is the program here? Void setup. Same like previous one in digital mode. Here now pin mode 11 output we are giving are the different blocks what we have here. See, analog write 11 0, because previously digital write was there. Now it is analog write here. Analog write, right? Now 0, 50, 100, 150, 200, 255, 200, again down to 150, 100, 50. This loop will continuous. Okay. So for every statement, we have a delay of 1 second. You increase or decrease, up to you the delay. So this is the code, and this is the blocks. So I will go for the blocks now. Still the program is, I want to run. You can once again I will run this. Okay, so this is the output. If we have any doubts till now, we'll give 2 to 3 minutes. 2 minutes I will give, then we'll go for the Salah. Okay, now it's your turn. If anyone having, you can have in the charts. Okay, charts it's showing here. Oh, Sami, if you can read this chart. Yeah. One question is, but if they did put 999 still work, you'll see why why it is working. We'll see here, because 255 is the maximum. If you go for the more, we'll see here. See, I will remove this one, or okay, I will put it here. It will work because 255 is the maximum. Just remove. No, where it is remove. Yeah. First 0. Let us take then 255. See, another wait. I know. Wait. Okay, keep it here. Now start. It is 0 to 250 on off. It is like high low for every 1 second. Now what you are telling, it is 9999. Oh, if you are typing, is it working or not? Check. It will work, but the brightness is different because the value what it is taking, it will convert to some voltage. So that is a drawback of this blocks, and it will take that value and it will convert to the voltage. The brightness is not like that. 255. Check here now. 255 is the maximum brightness. Some limitations are there. We have to follow those limitations. See, maximum brightness. Okay. So this is your charts. Where are my charts? Okay. Yeah. What do you mean of this one? Salamat. Okay. Okay, we'll stop here. We'll go for the Salah. Then we'll come back. Okay, everyone, welcome back. Mm, okay, so we'll go again to Tinkercad. So here, this pins with different setups. Again, duplicate it so that I want to save this one. That's why I'm making once again. This is 50 and this is 100, 150, 200, 255. Okay. Okay, from here I will duplicate.
Excuse me, Dr. Jafar, you do not share your screen.
Oh, wait, just hold on. Where is my zoom? Yes. Oh, you removed that one. Okay, okay. Share now. Can you see?
Yes, yes. Okay.
Yeah. What is it? Chart. Okay, I set back to the previous position, that is with different blocks. So up to 255. Again, from 255, I will go to the 200. Next 150. Next 100 and 50, and remaining you can remove it. Okay. This is set. So start code 0, 50, 100, 150, 200 and 255. Again 200, 150, 100 and 50. Again 0, it is coming. Okay, this is the previous one. Now in this, if you see these blocks, these are clumsy, means many blocks we are adding. Now if you want to make it simple program with the loops, so for the same output, how it will be, it is very good, right? So for that I need a new program. Just I can go here, Tinkercad, go back. Now here another technique I will show, because I want to use the same circuit but with different program. So no need to use a create new circuit and again put the Arduino and put a resistor and LED and connect it. No. So now here you go to the previous circuit options, you have duplicate options is there. So just duplicate it and it will duplicate and it will open. Yeah. So copy of LED analog output, it is there. Now I will rename this LED output with loops. LED analog output with loops. Okay. Now why I did, because I want to save time. Okay. Yeah, just I put it here. Same, go to the code. Now I can modify these codes because the previous one already saved in another file. Now just remove to put in the garbage. Now freshly we'll start. Now first that what we need, a variable. Then we'll create a variable I. Let us take some name. You can put any name I. So three blocks it's created with variable I, and set something to that I with some value and change I with some equations like that. Three blocks by default it will create every time. So now use this set I here. Now next we go to the first set I to 0 because we want it should be by default in off position. Okay, so that's why set I variable, or you can delete I variable or rename variable also option is there. Now you are setting the I to the 0. Now first you want to set some output. So set the pin analog, set pin high. This is digital. Now this is the analog. Set pin 11 to 0. Let us take. Now I can use the 0 variable with a variable. Means whatever you are having in the I, that will be given to the pin number 11. It's very easy. Okay, now use change I by. You can use change I by here. Some 50. Let us take. Every time I want to increase whatever it has, change I by 50. And controls I use, wait for 1 second. Okay. Now just put it here. You can have just these 3 block again. So I will put it here. Now here change I by minus 50 because I want to decrease. Every time I want to 50 increase, I want to decrease 50. Now here the two setups are ready. Now first loop should be with increasing 50 and next loop should be decreasing 50. So what we need, a repeat loop. So repeat loop, you take it and keep here on this block. Now repeat while we need I must be less than or equal to 255 until it has to repeat. So math, you can take the condition control, you can put it here, keep it here. That's it. Now what has to be checked? Variable, that is the value. I should be here, keep it here, and it is less than or equal to, see many variables are there, many conditions are here, less than or equal to 255. Okay, now next there is repeat function is there. So this will repeat until the I value is 255, less than 255, means it will stop at 255. Now another while loop we can have, that is a repeat loop. You can place it here for this. Now here for this while, same again, math control, you can use it here, keep it, then use variable I here. Here we can use greater than or equal to 1, unless it is greater than or equal to, means it is not, it should be going to more than 1. Now set this I equal to 0, because every time when it is become 0, it will come out from the loop and again it will go to this loop while repeat increasing loop 50 50 50, and next when it is finished to 255, it come out from the loop and it will go to decrease that one. How much? Minus 50. Every time it will minus 50. Now see, now start the code. We can have, see the brightness increasing, again decreasing, step by step it is decreasing, off, again increasing, increasing. So this is small loop, we can have this one. Okay, now if you see the code here, there is a code I equal to I plus 50, I equal to I minus 50. Every time we have minus 50, you can have. So very simple code we have. We are initializing I equal to 0, that is set I equal to 0. Void setup, we are giving the output to the pin mode 11. Now in the loop, again we are giving I equal to 0, no problem. So while I is less than or equal to 255, same equation, and log write 11 with the I. Okay, so this is by incrementing step by step, 50-50. If you want to increment with a small value also, you can increment with 1 1 1 1 also, you can increment, but it will take much time to give the to see the result. So 50% is good, 50-50 number is good. Okay, so here this is about the analog output with loops. Okay, what are the charts? Any doubts? Hmm. Guys, I have poor in Arabic. I have to copy this one. I have to translate. Better, Ahmad, you can translate these charts. What are their doubts? Ahmad, are you here? Can you hear me, Ahmad? Ahmad Sami. Okay, Ahmad Sami is telling charts are not that much important. Okay, no problem. We'll go to the next one. Uh, They're just asking about the time. It will okay, no problem, no problem. It's up to 9:30. I can take. If you permit, I will go to the 10. No problem. I told you we have 12. We have to go up to the 18 circuits. Okay, no problem. I will continue because I should not waste time. Your time is very precious. Okay, so we'll go to the next one. Thank you. Uh, just stop this code and we'll go to the next one. Let's have traffic light. Next one, I can say here, see, LED control, it is already over. Now we'll go to the ninth one, traffic controller circuit building, traffic controller circuit. I will copy this so that you should not waste time. Now create new circuit. Now, yeah. Okay, now bring the Arduino, please. Here, I got the Arduino. I will keep it here. Now here for many other components, if you want to add, it is better to use breadboard, small breadboard we can use, so that many positive terminal, many negative terminals I want to use. So you can use the breadboard and you can rotate this. How the breadboard function I will show here. See here in breadboard, plus and minus some terminal name is there. This completely, if you place the cursor on the first point, it is showing all the green circles, means internally from the back side it is shorted, means all are internally connected one. You can, if you use this as a one pin, all are same pins. So same, this is the second one for minus. Generally we use this for negative terminal and this is used for positive. Like this we have two here also. This is the positive terminal for all the pins and this is for the negative terminals. Now coming to the this one, this you can see A, B, C, D, E, but you can see here also number 1 to 30. So if you check number 1, if you move the cursor on here, it is showing horizontally 5 pins, 1 2 3 4 5, A, B, C, D, E. These 5 pins are internally shorted. Okay, so if you use one pin as an input to that this horizontal line, then you can use remaining this pin as a one node. So this will act as a one node. Okay, second node, this is all are horizontally shorted, but it is breadboard is I rotated for your easy understanding and for my connections, but I am showing the practical way what it is connected or not. So it is horizontally connected and these plus minus are vertically connected inside. Okay, that's you have to know. So this is one part of the block. of the breadboard. This is the second part of the block of the breadboard. Now we'll start our connections. What we need three LEDs. Traffic light. What are the traffic light lights are there? One is red, yellow, and green. So we need three LEDs. Just take one LED, and I can rotate this one. Okay, now place it here because I need a connection. So place here on the top one. You can place, and you can have red. Okay, no problem. Another LED, and okay, okay, rotate. Okay, now rotate this and keep somewhere here. Now, how the traffic light, you can tell me now? First, topmost, it is red. The next one is yellow, right? You can place that one. Next, I can have another LED, rotate. I am rotating more. Okay, now place it here. Anywhere you can place. These two terminals are placed in exactly the horizontal one, two different nodes. So this should be green so that you can go. Green. Okay. Now I got how many connections? 2, 2, 4, 5, 6. For each LED, I need 3 resistance. Means one resistance to each. So this also you can rotate, and you can connect either this is LED. You can connect in the anode or in the cathode, up to you. Generally I will connect in the cathode, don't worry. Disconnected here. Another, this should be how much we are connecting for? 150 ohms. Next, rotate. Okay, this should be connected to another cathode here for green light. Okay, no, sorry, I missed to have change the resistance. Now rotate this to 150 ohms. Later we can change also, don't worry. Oops, sorry. Now keep in the cathode. Okay, these are the, sorry. Okay, I will keep it here for your easy understanding. Okay. Now I am connecting pin number 2 digital, pin number 4, and pin number 8 as a output. You can use any one or digital pins. In this, pin number 3, 5, 6, 9, and 10, 11 are act as an analog pin also. So you can use any one. But my choice, I took those numbers 2, 4, and 8. That's like multiplication, I can say, to remember easily. Now for ground, we need a one ground. I will give here. I'll put it here, and I connect this ground here. I use black. Okay, this is the ground pin. Now I connect 2 as a red. Where is the red? Here. No, this is, there is a red. I can use this, and red wire I connected to the anode, that is positive terminal of the LED, to the pin number 2. Now next 4 I will take. Now I will connect this to anode of the yellow. Anode is here. Yeah. Don't worry, these are just simulation. Nothing will happen. If any wrong is there, we can identify and we can solve the problem. This is yellow. Yellow. Okay, next 8. What's going on? Yellow 8. This is green. Okay. Okay, what are the charts? Is anything? Okay, no problem. So all the set. The circuit is ready. So I can go. I will move this to here. So in traffic light, how it will be? Red, yellow, and green. So now we'll start programming. Code. Now coming to the code, I will move this somewhat bigger. Now I will remove this to the garbage. Now first I need 3 outputs for these 3 LEDs. So we cannot use built-in LED, we have to use some pin number LED. So we need only high low, not the brightness, just we have to on and off, right? So use the set pin 1, 2 and 3. So where it is connected, where that is important. So it is connected to 2, connected to 4 and connected to 8. Okay. Now in general practice, first the red light means if anyone is coming, he has to stop first. Okay. Then green light will glow, then yellow will come, then again red will come. So first 3 pins will define the first loop, that is red should be on, remaining 2 should be off. So off, that is low for the yellow light, low for the green light. Now I can copy. Okay, we can have some weight control, drag it. How many seconds this red light should be on, or how many seconds these lights should be, all lights should be on or off, that it is wait second. So I will say let us take 10 seconds. Okay, now I will copy all these so that we have 3 conditions here. One is red light sometime it should be on, then green light sometime it should be on, then yellow light has to be on, and it should continue. So 2 sets we need. Duplicate, keep it here, or you can keep it down again. Duplicate, you can keep it here. No, this is the problem. So we can have, can remove this here, so that you move down, easily insert here. Okay, 1 set, second set, 3 sets we have now. Only conditions we have to apply. So first we have to open red light, next alatul green. In traffic light, how it will work? Red, then green, then yellow. So green light should be high, that is down. So this is the high. Green light is on pin number 8. See, pin number 8 is green light, so it should be high. Remaining 2 should be low. So how many seconds? I say 6 seconds. Don't waste time. So I cannot use the practical traffic light what we are having. That much time I cannot put. You have to be bored. Okay, now next come to set the third one. Third one means we have to on yellow light for the caution, means you have to stop. Before stopping there is a caution, yellow light. So this is should be low and this should be high, this should be low. What is the time? Yellow always will have very less time, 4. Okay, 4 seconds. See, green red light 10 seconds, you have to stop much time. Next, green light, you have to stop for we have to start and going for 6 seconds. Now yellow light is for caution for getting stop, so 4 seconds. Now see the output. You can observe here the when the program is running, you can observe the timing also. Start simulation, it's everything is ready now. See, 1 second, 2, this is 3, 4, 5, 6. What's happening? No pin is on. Why? Stop simulation, see the circuit. Yes. Why? Can anyone answer me why it is not working? Because the negative terminals are not connected. We given ground to the breadboard, not to the LEDs. Good. This should be, you know, with practice only you know how to connect this. So I'm connecting the first LED to the ground, black. Next, second LED to the ground, again black. Third LED to the ground, black. So now all connections are finished. Now start simulation. See, red light alatul start. Next for 10 how many 10 seconds? Okay, we have to wait for 10 seconds. 8, 9, 10. See, green, go. Then this is 6, 16. At 16 it has to yellow. 10 plus 6, 16. Again at 20, red. So this, like this, the traffic control lights are working. Okay, this, if you see the, once again, if you want to see, you can have first red, first will be red, then green, then yellow, again red. Now red. Okay, so 1, 2, 3, finish. Now, if you want to see the code, you can see the code here. See what we are doing at pin 2, 4, and 8. You are giving the output as usual. Now, in digital write for 2, 4, 8, first one is high, the remaining two, that is red is on, green, yellow, and green is off. For how many seconds? 10 seconds, 10,000 it is. So it is Ashra Alf, means 10 seconds. Now, digital write for 2, 4, 8. We are owning only green light, that is for 6,000, 6 seconds. Now digital write for yellow light is on, that is light number 4, pin number 4, for 4 seconds. Okay, so this is your code. Okay, start simulation. I think no need. You want to see, once again, you can see I have 10 seconds. Then I will go for the another example. One example. Now here the complexity will increase now step by step. These are very simple. Now next we will go for the servo motor simple circuit. Servo motor is a motor where the rotor of the motor will rotate with the steps from 0 to 180 degrees only, from 0 to 180 degrees. So we have to build some blocks so that it can rotate from 0 to 180, from 0 to 180 degrees and 180 to 0 degrees. So that should be our aim. Okay, I stop this one. I will go to the main page and I will take new one, create new. So the all circuits are saved here. Very good. I will go for the new circuit. So here go this traffic light control finish. Now servo motor circuit. Okay, we can have here servo motor circuit. Now go fast and take the Arduino. Now here I want to rotate the Arduino so that it will look like we are rotating servo. Next, check where is the servo. Yeah, micro servo motor we are taking. Now in this servo motor, we have 3 connections. One, we put ground, beside is power 5 volts, and beside signal, means here is a control where we can control the steps of movement from 0 to 180 degrees or 180 to 0 degrees. So by giving the feedback or voltage, we can say, we can control the movement of the servo. So you can connect step by step. Now I will connect ground first. Okay, go. Yes, no need of here breadboard, only 3 connections. Sorry, go here. Connected. Now it is black because it is ground. Now 5 volts. We have to go here 5 volts. I will go from here to 5 volts. Here there is a 5 volts supply. You can directly get as an output. That Arduino has so many features. This is one of the feature. We can have supply voltage 5 volts source we can have. So this is red. And we have 3 grounds. Now the control. The control should be given from one of the digital pin or analog pin. It should be analog pin. If you give from the digital pin, then it will start and stop. That's it. It will start with by default 5 volts, it will go some angle and it will stop. That's it. But we need to move the servo with a steps up from 0 degrees to 180 degrees. So for that we need one analog pin. So I choose 9. So I choose 9. I choose orange, same color. Let us take, because the pin is here, same color, orange. Okay, circuit building is finished. This task is very easy. Main task is coding, how to control. So I will maximize this. Next, remove this default code. Now, again, I need a variable, what is called position of the servo. Position underscore servo. One variable I create. So 3 blocks is created. Now I have to set, by default, the position should be 0. So that it has to come back to its original position, whatever the output we are giving from the pin number 9. But at the last, it has come back to its original position 0. So that's why we are setting position servo to 0. Now we have to rotate the servo. For that, we have output, one direct block we have. Where is there? Yeah, rotate servo. Yes, we have the one block direct by default we have. Rotate the servo pin. Where is the pin? 9, pin number 9. This is analog pin. Now to what? We have to rotate that variable position of the servo, which is by default it is 0. Now we will rotate to the position of servo with some degrees. So that equation will come. Now we will wait for, so that servo should not be moved in a fraction of seconds. The mechanism will fail. The gearing mechanism will fail. So that's why we have some delay, 10 milliseconds let us take. It should not be instantaneous. If it is instantaneous, means it should be a general DC motor or AC motor. That is smooth, instantaneous, bearing will be there. But here the gears will be there. So the gears may turned off or tore off and may damage if it is very fast movement is there. So we have some delay of 10 milliseconds. Now what we need, we have to duplicate these blocks. So I will keep it here. Now I need to repeat these two. One is from 0 degrees to 180 and from 180 to 0, like what we did in LED analog output. We are increasing the brightness and decreasing the brightness to 0. So for that, what we need? A count we need. A count we need here. I will place it here. Okay. I place here count. So count up means from 1 for, what is the variable here we're using? I. No, you can remove the delete I variable. We need only position. Oh, what happened? Okay, no problem. Rotate here. We need control count up. Okay, you can count up here. Count up variable position of servo we can use. Position servo we can use. Then only we can delete that one. Otherwise, complete blocks are going. Okay, now from 1 to 179 degrees, 1 to 179, some steps it is going, 1 to 179 steps. Every time 1111 it will increase. Okay, so this is one. Again, I will duplicate this block and I will keep it here so that I want to count down from count 179 to 1. You can use 0 also, but sometime it will slip the gearing mechanism of the servo and it reflects not as a normal servo. So that's why we want to avoid that problems. So we are using up to maximum value 179, not 180 degrees, minimum value to 1, not 0 degrees, because 0 degrees already we are placing at the top. So you can put this top here. For every loop, it will have this one. So my programming is done. It's very simple, I think. Now see what we did. We set the position of the servo by creating a variable to 0. Now we are counting up 1, means 1 by 1. We can have some different value here, so that step by step we can increase to 5, 5, 10, 10. If you want to count, you can count, no problem. Multiple of that one means addition of that 5 plus 5, 5, 2 plus 2, like that. So for position of servo from 1 to 179, between 1 to 179, we are incrementing by 1. You can change this value, no problem. Okay, then it will go inside the loop and rotate the pin servo on pin 9 with the position value. What is the position value? Already we have from here 1 to 179. 1 by 1 it will increase to 179. It will wait for every time 10 milliseconds. For every time 10 milliseconds means how many seconds? 10 milli means 0.01 second, very small value. Okay, here one mistake we had, same copy paste it was done, but we didn't cross check it is up or down. What we are doing? We are doing 179 to 1, that is down. So it will count down from 179 to 1. Again come out from the loop and it will go to the set position to 0. Okay, everything is ready now. Start simulation. See, right, my servo is rotating. What it is doing? Clockwise, anti-clockwise. How much? 180 degrees. 0 to 180 degrees. I can say 1 to 179 degrees, but it's coming back to its original position to 0. So this is servo circuit, very simple circuit. Only we have to think about the how to use the blocks and how to place the blocks. What are the constraints we are facing by using the blocks? That's it. Okay, any doubts? So we want to see, you can see the code. Go to the block text, see here. Because we are using servo motors, rotate servo pin we are using. So by default block, there is a library we call, it has its own default programming, how to rotate the program, how to give the signal to the servo, that all programs will be included in this file servo.h, that we are not studying that one. Only we are using that program to include in this current program. So we are initializing position of the servo equal to 0. I think I is equal to 0 now, no needed, though it's waste line it is. Now servo, we are giving servo to 9. So here we are giving the control to the servo attach from 9 to 500 to 2500. These are millivolts it is there. Now void loop, position of servo is 0. Now from position of servo 1 to 179. I will open this here. Position of servo is 1 to 179 and it will increment with +1 every time. So that is what it's saying. Now every time the position servo will get that value and it will rotate a 1 degree, 1 degree, 1 degree, it will rotate, and it has the delay 10 milliseconds. Okay, now here also delay 10 milliseconds inside the for loop, because it is 10, it is showing it is in milliseconds, where we are using milliseconds, but in the program by default it is milliseconds, so 10. Okay, next come to the blocks. So this is your servo. Okay, next we'll go to the another one. We have gas sensor now. Gas sensor will go. Simple sensors we'll study. Next we'll go for the LCD control, and many will study this one. Okay, now go to the new one. Okay, see already servo circuit it came. Now create new. Now go here, we already finished this servo. Now come to the gas sensor circuit. I will change this. Okay, it's ready now. Now go to the Arduino. I'll take this Arduino and I'll keep it here. Okay. Next, I need a breadboard so that I can connect easily. Without breadboard also it's okay, but we have many connections. Because gas sensor, when it is detecting, we must have some output. It will be on buzzer, means some buzzer means here this is piezoelectric buzzer. It will have sound output. It will have some dampers or vibrating dampers will be there inside. It will vibrate. You will get the different sounds with the different tones we call that we'll study. Okay, I will rotate this buzzer to 180 degrees. Now I will keep somewhere here. Now what we need? Gas sensor. Now, can you see the gas sensor? No, I need all components, then I can see the gas sensor. Yeah. Okay, gas sensors are here. Okay, anywhere you can connect. Now you have to know the connections. Okay, the buzzer is by default we are having one positive and one negative terminal. Okay, before going to the connection of the buzzer, I will connect the positive and negative terminal to the breadboard from the Arduino. That is from 5 volts. I will take here. I will connect here because this complete line now it is 5 volts, one connection it is. So it is red. Now I will take a ground. I can connect ground here, but maximum my ground positions are here. So I take ground from here. We have 3 grounds. Any ground you can take. I will connect from here. Okay, black. I connected, or I can use like this. Something like that. Okay. Positive negative are ready now. Next. So negative. This negative to the buzzer, I'll give to here. This is negative black. Now positive. The buzzer positive should be, you can give 5 volts, but what is the problem? The problem is if we give directly to the 5 volts, what is it will active for all the time. It will give the output, means it will give the sound every time. It will not stop because we are activating from with 5 volts. But our motto is when there is a gas detected, then only it has to sound. It has to give a sound. So for that, what we have to give? We have to give the connection of the positive of the buzzer with a output of the Arduino. So we have how many outputs here? 0 to 13 outputs we have. So in this one of the pin you can choose, and I choose analog 9. We'll see why analog 9 later. Now I will just connect this to here. Now this is orange. Okay, buzzer is connected. Now coming to the gas sensor. Gas sensor has 3 connections here and 3 connections here. 3 connections here are B1, H2 and B2. These 3 are given to the power supply because one connection is for warming the gas sensor, another is for detecting. Like this, we have different circuit inside. We are not going in depth of the structure of the gas sensor, what is inside. First we have to follow the connections. So these 3 are the connections. These 3 are red and we are giving to the 5 volt supply. They need 5 volts. Now we have another 3. So In this another three, one is ground. These three are generally ground, but we are giving one as a input to the Arduino. What is that input? Is A0, that is last A2. It is input to the Arduino. Go here. Next here and connect it. Sorry, I can give this purple. This is as an input it is acting, and the middle one is direct to the ground. Where is the ground? Yeah, this is the ground. Be careful. This is black. This is also a ground, but we need some resistance to drop the voltage and to limit the current. So for that, I need basic components and one resistance, and I have to rotate to limit the current. So I'll put it here, and I can put it here, and I put this as a negative black. See, this connection is already shorted from inside. So I took from this node for one side of the resistance, and other side of the resistance I shorted to the negative, which is given to the ground. Okay, so we have finished our connections now. All are set. Yeah, this is given from the 9. This is given to the ground, and this is for A0 acting as an input to the Arduino. Now remaining two are the this one and this resistance. You can have 1 kilo, no problem. We will see. Okay. Then we'll go for the code. Just observe. I will move for somewhat and go for the code. It is very easy. Now remove this. So what we need a variable V gas. Let us take one variable we create. Voltage for the gas. One variable will create in which the value will be saved. Now we have to set gas here. Now from where we are getting the input to the gas, we are getting input from the gas sensor. A0 pin A0 we are getting as an input from the gas sensor. So we are setting V gas, which must be given from A0. So here we need some input. So read analog pin. So how many pins we have? A0 to A5. We are reading for reading. These are output for digital and analog output. So read analog pin. You have to drag this and keep it here. Now it is set. So set V gas analog pin. Now we have to play sound. So we have to give the output where play speaker pin. See, play speaker pin. Keep it here. Okay, I need some more space. We can have, okay. Now play speaker sound, where it is connected speaker. This is orange 9 analog output 9. Now what is the tone? Means different sound. What we call tones will come. You'll observe what exactly I want to say. So we have tone values from 0 to 12,000 to 39. Different tones, different pitch, we can say, means different heads, frequency of tones we have. So first let us take default 60 now for 1 second, no problem. Now when this speaker has to be played when there is a gas is detected. So for that what we need a if condition. Control if, we need if condition. You'll keep it here and set it here. Now what is the if condition? We must have a control, math control, that is you keep it here. Now what we are seeing, value of the gas means the intensity of the density of the gas. So what is a variable? V gas. V gas is having that value. It should be greater than 200. Let us take You can have anything, but it should be 200 or 250. It is called as a much denser gas, which will harm the human lungs or environment, we can say. So, okay, now everything is set. Pin number 9 we set for the player speaker, and 60 is the tone. Now we'll check the output. So I'll decrease this one so that you can see easily. Okay, now start the simulation. Everything is set now. Now simulation is started. Now if you click on the gas sensor, it will show the gas simulation. See, it is here now. Now if you move, click on that shape and move here and there, means the value is not more than 200. Now if you move further, nearer, still it is not 200. Now it is now more than 200. Now it is not. Right? So if you move further, then now what is the tone? So you heard the 60 number tone. Now I will put 500. Let us take. Now play the sound. Now check. Move the gas. Different pitch, different sound. So we have how many sounds? Yeah, because the delay is 1 second. It will wait for up to 1 second. It will buzzer. It will give the sound. Now, how many sounds I told? We have 1, 2, 2, 3, 9, 1000. This I came to know by one increasing the value. More than this, it will not work. I will show. Don't worry. So it is. Check here. Different sound. Every time different sound with different tone. Okay. This is a different sound. Now I increase if more than this to 1, 2, 2, 1, 2, 2, 4, 0, 1, 2, 2, 4, 0. It will not work. See, error. There is an error. It's showing. Sorry. What is showing? It seems like your code has some errors. What the error means? It is the tone value. It is problem. So 2239 is the maximum from 0 to 12239. Now it play it. It's working now. Okay. Now let us take 0. Okay. So it work on integer value from 0 to 12239, means 12,239 the tone value. So very simple program it is. Okay. So this is about your blocks. See here, for sensors by default blocks are there. We can easily connect it and you can program it by using blocks. Okay. Okay, next we'll go for another one. Any doubts? We finish the sensor, gas sensor, then ultrasonic, then temperature. 2 are there. Then we have the good one, 736. We have to finish in this time, ultrasonics and temperature both. Otherwise, time will not be sufficient. Create new. Okay, I will put ultrasonic home, ultrasonic distance sensor. What is the question? Okay. Now, next coming to the same thing, coming to the ultrasonic. We need an Arduino. Okay. Grab it and keep it here. Now we need same buzzer. Here, I don't use the breadboard because we need distance. So we need a more empty space I need. So where is the buzzer? Yeah, buzzer I will put it here. Now I put ultrasonic here and I will rotate this. Yeah. Okay. Now I'll put here. So That's, you already know it. This is positive, and this is negative. Give to the negative to here, and ground. You can have this, and this should be the black. Now this positive should be given to pin number 10, analog, because we are following the tones. So pin number 11, I can have orange. Now see, in the distance sensor already showing ground, 5-volt supply and signal. Means we must have distance as an input. How much distance it is sensing, it should be given as an input to the Arduino. Okay, so just connect in very easy manner. No doubt. Signal should be A0. And this should be purple, I can say. Now we'll connect 5 volts. This will be red. Now next I connect ground. Grounds anywhere you can connect. We have 3 grounds. Now this is black. Connections are finished. Oh. Array connections are finished. What is the chart? I didn't understand. Type it in English, please. Okay. Now coming to the code, just remove this and throw this here. Now I need a variable, as you know, distance. How much distance I have to know? That variable I do the distance. So we have to set the distance, right? We have to set the distance. So from where we are reading, from A0, and that is connected to ultrasound. So no need to worry about, we have input directly. Okay, raised hand. What is the problem? Who raised hand? Amjad. Any problem, Amjad? You can have in the chat. Okay, so we have to read the distance from A0 pin, which is connected to the ultrasonic sensor. Now there is a by default block, read ultrasonic distance sensor. See, directly you can take it and keep it here. So that's why I put more bigger one. Okay, or I can have, yeah. Can you see it? Yes. So what we are doing, we are setting this to a distance as a variable, and we are reading ultrasonic distance sensor on trigger pin A0. Where is A0? Here, from A0. E0 echo pin, same as trigger in centimeters you want to measure or inches you want to measure. We'll see centimeters first. Same as trigger, how much it is showing, that is means same as trigger, how much it is giving the input. Now we'll need play speaker, so output. So play speaker on pin number, we'll put it. Pin number please, 10. 10 is the pin number. Tone, okay, we'll decide. Now another, we have to play the speaker and we have to stop the speaker. Okay. You have to play the speaker and we have to stop the speaker. So we have turn off speaker also. See, turn off speaker on pin number, because once it is activated, we have to stop that also. So pin number 10, same. Now we will put a if condition, that is for controlling. If else we need, because not only if, we need if else. Now remove this and keep here. Okay, and now remove this and keep here. Okay, now put this if condition set here. Now what is the if condition? If condition, we have to put the mathematical control, put it here, mathematical control. What we are reading? We are reading distance. We are reading distance and we are checking distance is, if it is less than okay, less than 20 centimeters, let us take. Then play speaker, means where speaker should be give sound for 1 second. If it is not less than 20 second, it is greater than 20, then speaker should not be played. Okay, so it is, everything is set now. Now I have to move or I have to close this code and you have to start simulation now. Now if you press on the ultrasonic sensor, the distance will come. Press it. See, now this is the object to which it is sensing. This is the object, the round circle where you are standing. I can say how much distance you are standing away from the ultrasonic sensor. So if you move this, it is showing how much maximum it can show. See, 132 inch it can show. So the ultrasonic distance has the limitations of 132 inch, that is 335 centimeters, and minimum also is there, 1 inch. Minimum is 1 inch, 2.6 centimeters. So ultrasonic sensor has 2.6 centimeters to how much? 350, 335. That is 131, 132 inch. How much 132 inch? I think 11 feet. Okay. So this is, we have ultrasonic. See, when you come to the closer, 20, less than 20 centimeters, I'm talking. See the down one, not the inches. It is centimeters, less than 20 centimeters. Displaying. More than 20, it will not play. So if you want to have different tone, you can have different tone, like 1, 2, 2, 3, 9. Then code, you start here. Different tone of the, so this is, it is stop. We're taking 1 second to stop. Meanwhile, you cannot push so fast, even though it will take 1 second to stop, right? Because we put for 1 second to play the sound. Okay, this is another one. If you have any doubts, you can have it. I am moving to another circuit. This all we will use in the further circuit. Buzzer we'll use, and LEDs we'll use, and we'll use temperature. The next one we are coming. Now this we finished. Now coming to the temperatures. Okay. Now we'll go to the new. I think I explained everything here. Very easy. Now create new. How much time left for this Salah? Okay. Oh, 6 minutes are there. Just we'll connect the next circuit, then we'll go for the Salah. Programming later we can do. Very easy. It's temperature circuit. It is, or some codes also I can tell. Okay, home temperature sensor. So for that we need a Arduino breadboard. Keep it here, and we need a breadboard. Directly also you can connect, but it is utilized for further. That's why I'm using this one. Before that, I will use this positive to the positive 5 volts. I will take and I will connect. This is the red, and the ground I will take. Any ground you can use. This is black. Okay, now what we need a temperature sensor. We have a temperature sensor here. Here many calculations we have to follow, so bear with me. Okay, I will put it here, temperature sensor. Somewhere I can put. Okay, now in temperature sensor we have only three connections like a servo, power, V out, and ground. V out means we're giving the output from the temperature sensor and input to the Arduino. So just give the power to here 5 volts, which already connected here, and ground to here. Sorry, here. Power is red and ground is black. Now this one very important, that is called out. I will give as a input to the Arduino. Okay, this I will give orange. Okay, all connections are over. What is it? Chart. Akhar al Mahazar, 210 Sashra, I think. Now another 2-3 minutes are there. Okay, this is finished. Connection is finished. Temperature. Now coming to the code. Just remove this and throw here. Now same thing. What we need, a variable. So that variable I have to create temperature. Temperature variable I created. I kept here. Now we have to read the temperature. From where we have to read? From A0. So set temperature and we have to get the input. Read temperature sensor pin already is there. A0. If you are to change the A0, you can change. You can connect anywhere from A0 to A5 and you can change here. But by default, we are taking A0. Now in units degree centigrade, you have to measure unit in degree centigrade. This is one option we can have. And if you want another option also we can have, that is read temperature directly. We have read analog pin we can have, that is by default block is there, no problem. Simple I don't want to go because in future that may not be required. That is very simple. Directly it will read in temperature in degrees. But I want to show how to map, how to differentiate different ways. So I am reading temperature with read analog pin A0. Okay. And we are equating to the temperature. Now set temperature to, that is for variable. Set temperature to, we will keep it here. And we have one math control map, because we are setting this temperature sensor has limitations. It can measure from -40 degrees to 125 degrees only. So for that we have to map it between -40 to 125 degrees. So here we can write range -40 to 125. This temperature sensor quality is that you can measure -40 to 125 degrees centigrade. Now in this map we have some equations, that is equation is this one you can have, and read pin we can have from input. Read analog pin A0 we can put. Now this value should be negated with 20. This equation I will explain after this, Allah, don't worry, because we don't have much time. I am just writing, and this has to be multiplied. Okay, here. Okay, this completely has to be multiplied with 3.04. You can put it here. Yeah, I can take this. No, just hold on. I will keep it here. You have to put in here. Now multiply this. Multiply 3.04, because we are getting voltage as output from the temperature sensor. That I will explain. Now this should be placed in the map here. Okay, now the map is here. Now set temperature here up to here. Okay, one by one I'll explain. Okay, stop for the Salah prayer now. Yeah, sure. Okay, we'll come back again after 20 minutes. Then we'll continue this. And I have another three. I think this is the 15th one, right? 13th one. Oh, we have more. We have to go fast. Okay, no problem. Go for the break. Thank you. Welcome back. Let's continue in fast manner because we have only, I think, 1.5 hour, 1 hour, 40 minutes. We will go in fast manner, and already you are more familiar with the circuits. So just I will explain the logic and why the blocks I am using. I will explain one by one. So I have to share the window. Where is the Zoom? Yeah, share it. Okay, yeah. So you can see me now, my screen. So where were we? So we already set the temperature to read from analog pin A0. Now we are mapping the temperature between -40 to 125. We can map it, but the problem is what we are reading from the A0 will have the values from 20 to 339. The voltage, it is called millivolts, we can say. So that has to convert from that value. Thus, temperature sensor will give the output in serial monitor 20. That is -40 degrees. It will give as a 20, and maximum 125 degrees. It will give 359. So what the analog pins we have is the output will be in 8-bit. So in 8-bit means it can give the output from 0 to 1023. That is total is 1024. So the value it will give from 0 to 1023, 8-bit pin we can say. If you convert this to, it will be from range from 0 to 1024. But the temperature sensor can give the value for -40 degrees as a 20, and maximum up to it will go up to 359. That is for 125 degrees. So that much it will be read by A0. When temperature sensor is giving a 20 -40 degree as a input to the Arduino, then the A0 pin will read it as 20. Next, if the maximum value of the temperature sensor 125, if it is giving 125 degrees centigrade, then the A0 pin of the Arduino can read as 359. So this is the range what we are getting into the Arduino. So we are mapping that from with this equation, that is we are negating with -20 and we are multiplying with 3.04. Okay, so while printing you will see. So for printing into the serial monitor, there is a serial monitor where we can see the output from the Arduino, how much it is getting as a input from the temperature. Means what the temperature is giving, we can see in the serial monitor. So just we'll see as a output, print serial monitor. Now place it here. Now use as a variable temperature so that I can show you how much it is reading, what I told 22 1 339. So with without new line means we need continuous, not this one. Now another we will take as output, print to the serial monitor. Here I will type degree centigrade, degree Celsius. Okay, this is with new line, and control I will wait some seconds. Let us take 100 milliseconds. For every 100 milliseconds new reading has to be come. Okay, so it is now ready. I will explain this calculation in the meanwhile. Just check the output. Here is the serial monitor. If you click it, it will open. Now start the simulation. See, 25 degrees centigrade showing. Now, if we map it, if we go back, so here also on the temperature on the, I will zoom this one. Here it is showing 3 degrees, -2, -6. So some -15. So it is -40. So if we won't map this -40 to 125, it will not give this exact reading what we are reading from the temperature. That is, the input A0 pin will read from 20 to 339 from the temperature. So we have to map that one. Okay, so another thing I can add it. Okay, print serial monitor. Okay, no problem. So this is the temperature sensor. Further calculation will come in next program. So this is a simple one. Just we are connecting the temperature sensor to the Arduino, and we have to set that variable and a temperature as a variable, and that will be equated the reading from what we are getting from A0 pin where the temperature sensor is connected. Now we are mapping that reading which actual value to the equated temperature value. That is, actual value is in terms of voltage, in terms of bits, we can say that is 20 to 339 bits. So from there it is we are mapping to the temperature degree centigrade. Okay, like this in we can have degree Fahrenheit also, no problem. That we will study in another circuit. Okay, I will stop this here and I will go to the another circuit where further more detail it will be there. Now create new. Yeah, this is finished. Now in this I have very good one with LED, RGB LED I will use. Here I'm using temperature sensor with RGB LED. Just use this one. Right now same also I will not take any breadboard, directly I will connect the like previous one. Temperature sensor, we make it first part. What is this power? I'll connect this power to 5 volts. Okay, red one. Next I will connect this ground. This is orange and this has A0. This is orange and this is black. Okay, temperature sensor is ready. Now we need RGB. I will keep it here. Okay, now we need negative to the ground. Okay, now we need resistance, 3 resistances to 150 ohms. Another we need 150 ohms. Another we need 150 ohms. Sorry, this is wrong. This is ohms. Now connect pin number 10, 11 and 9 because we need analog. So this is 11. red, G blue. This is connect to here. This is blue, I can say. Next, blue. Now next green. I will show I am using this one. Temperature control. Okay, this is okay now. Okay, now connections are finished. Now coming to the code. Remove this. In previous one, I explained very little in terms of equations. Now I'll explain in simple way. Okay, now same use create variable temperature. Okay, now set temperature and output. Okay, variable set temperature and read it input. Now we'll see read temperature directly will take in degrees centigrade or degree Fahrenheit, whatever you want. Now it has by default controlling, default mapping, everything it has. Now what I am doing, I will give the three conditions. If it is greater than 50 degrees temperature is there, it shows the red light, hot nature. If the temperature is less than 50 and greater than 10, it should be blue, means normal condition. If it is less than 10 degrees, then it will show green. So for that, what we need a if conditions, a control all if condition, direct if conditions we can have. No need else because we need three. So now next we'll go for the math. For if condition, we need a control math. Now here we put temperature sensor inside. What is the reading? It should be greater than 50 degrees because we are reading the A0 and block we are using direct block read temperature sensor with A0 pin, and it should convert it into degree centigrade or degree Fahrenheit up to this. Now output, we need a output. So directly we have output one block Rgb. So no need of having different one, different three output connections. No need, direct block we have. So here set Rgb LED pin, where we connected this pin. We have connected three pins, that is 11, 10 and 9. So we can use 11 as the first pin because it is a red, and 11, sorry, this is 11 and this is 9 and this is 10 and 9, sorry. Okay, now whatever condition, temperature should be greater than, if it is greater than 50, then the color should be red we can have. So it shows hot condition. Now I can have duplicate this and I can keep it here. Now it is less than 50, above and less than. This is now less than 50. Now same, set RGB light 11, 10 and 9 to color blue. Now same thing, duplicate. Now if it is less than 10 degrees, then RGB light should be green. Very simple one it is, because we are taking simple block read temperature sensor pin A0 in units degree centigrade. So start simulation. If it is ready, yes. Now see the temperature. Why it is not coming? Because we are reversely connected this one. 10, what is the 10? It should be blue. So here the pin number has to be changed. What is the pin numbers? The middle one 11 10 9. It should be blue, and 11 10 9 it should be green. Okay, no problem. So start this. So maximum it is red. More than 50 it is red. Sorry, you cannot see this. Okay. See, less than it is green. So the problem is connection, because here we are connected different way, I think. Okay, now see it. Yes, same. Why? Because the pins what we set is the important. Less than 50, less than 10. Yeah, here you take green, here you take blue. Now see it. Yes, now it is working. So it is based on the RGB pin. Wherever the pin you connect, 11 10 9, it's up to the your connection matter, but the colors what we set, it is based upon the color. See, less than 10 I mentioned blue, it is coming blue. So between the 10 and 50 it is green. Now it is red. So this is our simple. We can control in physical way that if it is the temperature is less than 10 degrees, switch on the room heaters. If it is between 10 and let us take 30 degrees, we can have. If it is 30 degrees, switch on the fan. If it is greater than 30 degrees temperature, switch on the AC. Like that we can have the control. So it is, we can have the relays and we can control that one. So this is about the simple temperature sensor with RGB light. Now some more complex we'll go with potentiometer. The next one. Another two we have, that not much. Okay. Now we have both servo and temperature and potentiometer. We'll enjoy this one. This is the last with block sets. Then we'll go for the programming for LCD. Okay, now take the Arduino. We need breadboard, we need Arduino. And we need a temperature sensor. I'll keep it here. And I need a potentiometer. What is a potentiometer? I'll explain, and I will rotate first this. Potentiometer is nothing but a variable resistor, where from first point to the last point, the complete resistance will come into picture. If it is between first and middle point, the variable resistance from one point to another point, the variable resistance will come. If you move the potentiometer, it will come that one while running. Okay, potentiometer is set. Now we need a switch, slide switch. I will rotate this because I want to read in two way, from the potentiometer and from the temperature sensor. Okay, no problem. Okay, this is finished. Now we need a servo, khalas. And we need a LED with a resistor. We'll glow the LED also. And when resistor I can connect. Now we connect 5-volt supply to this board. As I explained to you, it's very good if we connect and keep it anywhere we can use it. The red and next ground. Black. Okay, here also I will connect this plus to plus and minus to minus so that I can use complete board. Because I am shorting the positive from there to here. We have to go fast. Okay. Is black. So breadboard is ready. Now our connections we have to make. Servo motor, what I told you, this is ground and this is power and this is the signal. So connect the ground, black, and this is the power. Next, and now we are not reading the we are moving the servo with potentiometer as an input or temperature as an input. So we had to give supply or control from this digital output. So we'll connect to the pin 11, no problem. Orange you can take. Okay, servo finish. Now we need two inputs, that is from temperature and from the potentiometer. First temperature will finish, power will connect the power here, red, and ground, black. Now power. Here also you can take the power from here, the input you can take. Okay, purple will take, and temperature sensor finish. Now switch. One connection is ground, I will give black. Now another connection I will give as a power, red. Now I will give a switch as a output so that it can be taken as a control. Okay, switch I will take as output to the pin number 12. As a control I can say this. Okay, brown I will take. Now only three connections left, that is potentiometer. This is red, power supply, and this is ground. Black, and this is, sorry, power supply red. Now this potentiometer we are connecting to second read. So I'll connect this potentiometer to A1. So the two inputs we have. Okay, blue we have. So my connections are finished. How it is working I will tell. Now here why switch I connected as an input, because these are the digital inputs, right? When switch is active, when it has 1, Then in the program, we can test that one and we can select one of the two devices, potentiometer or temperature. Now connections are ready. Okay, resistance not finished. Okay, 220, no problem, 150 ohms. Now we have to connect this to negative. And positive should be, the resistance should get the LED should get the input from where? From here, from pin number 10, analog, because I want to change its brightness. Okay, now coming to the code. I will just remove this. It's not that much big task. Just I'll create a variable, read value, maybe somewhere read value, maybe from the potentiometer or temperature. So we don't know. So we have to get the selection from the switch from where we are reading. Now we have to set the read value first, and set the read value from where? From read from analog pin A0, because we have to read from two places, A0 and A1. Read pin, analog pin A0, we'll keep it here. Same thing, you can have duplicate, read the value from A1. Read the value from A1. Okay, we are reading now. Now we have some comment here so that we can easily understand. So here, read the value from potentiometer. Okay. Next, here another comment, read the value. Read the value from temperature. Temperature sensor. This is a comment so that you can understand from where it is coming, how it is the program is running. Okay, now we have to set the set pin 10. Now we have to set pin with some value. Okay, set pin number, how much this, when we are reading the from the potentiometer. So what we have to set? We have to set the value. Set the pin 10, where the pin 10? Pin 10 is going to LED. So we are setting the LED with some equations. What is the equations? Math control, please. Here you keep it, and variable read value, how much? Multiply by 0.25. Now you keep it here. Now what we are doing? This is from potentiometer. Now this potentiometer I will put as a 10 kilo ohms, let us take. Now it will vary from 0 to 10 kilo ohm, but whatever it will vary from 0 to some X value, the A1 pin will get from this potentiometer is 0 in between 1023, that is 8-bit pin, from the value 0 to 1023. So if we are reading from 0 to 1023, now we have to set the pin with the read value. Read value what is? I will show here in the calculator. Read value is, it is 0 to 1023. That is 1024. Generally from 1 to 1024 we can say that it has read value. Now that value I have to give to the LED. There is a LED here where it is connected to 10. See this. 10. We are connected to the 10. So if you give the 1023 as a value to the 10, the brightness will be not much. So the pin number 10 is analog. So for the LED, what is the range? It is between 0 to 255. So we had to scale down to 255, right? So for that, I am using a scaling factor of 0.25. So now you multiply this 1023 multiply with 0.25. How much? It is 255. So at the potentiometer, when it is a maximum range, it will give maximum brightness of the LED. That one, right? That is my explanation. Okay. Now this is about the LED which is coming from the potentiometer. What is the LED brightness? Now what about the servo? Servo motor, we have to rotate the servo pin. We have output. Rotate the servo pin. I will take and will keep it, and it is connected. The servo pin is 11. So servo pin is at 11. Now how much we have to rotate? That is we have to calculate. So again, I am telling it is what the read value is getting is from between 0 to 1024. So the servo motor in degrees, from where it is calculating, it has to calculate 0 to 180 degrees. So I have to scale down to some value. So how much I am getting maximum? 1023. Now I have to scale down this value to 180 degrees. So if I multiply with 0.175, then I will get 180 degrees. So this is the way of calculation. Okay. So for that, we have to put the math control here, and variable read value, keep it here, and scale down, multiply to 0.175. Right. Now keep this here. This is about setting and rotating the servo and increasing the brightness of the LED by potentiometer. If you move the potentiometer, the servo should rotate from 0 to 180 degrees and the LED brightness from 0 to maximum. Same thing with the temperature also. With the temperature also, I put it here something. Now read value, if it is from the temperature, that is pin number A1, not A0, it's A1. So we have to first rotate the servo pin, or we can set input, no, output. Okay, set the what we called LED. So set analog pin. Where is analog? Yeah, set pin. Set is analog pin gray. 10. Set pin number 10. What we have to set? Again, we have to calculate. Now again, I told you. Where shall I write? Okay. Sticky note shall I have? Yeah. I will write here. I told you. Okay. Okay. Potentiometer will give the range. Will give the range between 0 to 1023. But temperature, I will write only temperature, TMP. Sensor will give in value from 20 to 330, 359. 359 it will give at A1 based upon the temperature sensor design. Okay, because 20 relate to the temperature minus 40 degrees and 359 related to the temperature of maximum 125 degrees. So this I explained in previous two circuits also. Now also I'm explaining. So we have to scale down this also. When we are getting 20 as a minimum and maximum as 359, then for LED, how much should be the maximum brightness? it should be the 255. So if we want, then we have to calculate and we have to scale it to 255. So for that I have one equation. Okay, math control complete here. Okay, variable read value here. Okay, now this I will multiply with 0.75. Multiply with 0.75. Now again math control I will take. Okay, I will calculate, no problem. If I multiply the maximum value 359, right? Okay, 359 if I take and multiply with 0.75, 269 I'm getting, but I should get maximum value of 255. So minus 255. How much it should be? 14.25. We have to get negated from the coming value maximum I'm telling. So for that, just you keep this completely here. Okay. Okay. So read the value and multiply with 0.75 should be minus with, where is the value mine? 14.25. 14.25. Okay. This you can put here. Good. Now for servo. Servo also we have to rotate servo pin. You have to take output. Rotate servo pin. Again, it is on, where is the servo pin? On 11, pin number 11, right? To 0 degrees. Now again, you have to use some math control. Here, read value. What is the problem here? I will multiply with 0.53. I will tell why it is 0.53. And keep it here. Another math control. And I'll put here this. And I will negate this 10.65. How I will tell 10.65. Now, what is the read value maximum? I already told you in this here, temperature from some temperature sensor, same thing. So 20 and 359. So 359 I had to scale down to 180 degrees, right? So 359 I have read value maximum. So multiply by 0.53. 0.53, sorry, 359 multiplied by 0.53, 190.27. It is not coming. We need 180 degrees only, or 179 also okay. So minus 180, 10.27. You can have 10.27. No problem. Now just keep this here. Now we can see the, oh, sorry. Now we need a if condition, because either the switch control is there, both we cannot work together. Or if switch is on the right side, then it has to take the temperature. If it is off, we have to take potentiometer. Depends. Now take the if condition control if else. Okay, put it here for everything. And okay, you can put here this. Okay, I got if conditions. Now we need if conditions here. So we need a if math here. I will keep it here. Later we'll inside. Okay, read from where we have to read from this switch. This switch is connected to 12. Now, okay, input. Read pin. It is digital. Be careful. That's why digital pin I am taking. If it is high or low, that's only the problem. 12. It's a 12, right? Digital pin I am taking. If it is digital pin is equal to a 0, let's see. equal to 0 and keep it here. Now what it means, if digital pin is 0, so here when it is 0 means on the left position which is connected to the ground and giving the supply to the 12, so it is 0, right? Now if it is 0, then where it has to go, it has to go read from the potentiometer left side. Now if it is 1, when I switch is right side, just like it's shown here, right side, then it should go else, that is take the reading from the temperature and move that. Okay, we'll start simulation. Everything is ready. See the duty now. Okay, because it is on right side, where it is going in the else condition, so just temperature sensor move. Okay, here on the left side I am checking. Now check the potentiometer. I think some connections missing. Read from analog pin A1. And analog pin A0, no problem. Rotate servo pin 11, right? Read the value multiplied by 0.175 degrees. Okay, read the value 0.25. This is set pin 10. 10, 11, 12. Okay. Somewhere where ground and 5 volts. Ah, yes. See the brightness. See the brightness here of the LED is going to the maximum. Now the brightness will increase if the value is, let us take 100. Okay. Now it will decrease the brightness because we have some delay. So that's why it will take time. This one. Now if you put the switch here, now we have potentiometer. See, I am rotating the potentiometer to rotate this one 180 degrees. And brightness also is there. LED brightness is also coming. So like this, we have either or control, we can say. Okay, now make the switch here. Now change, rotate this one. Okay, so this is a good one. What we have, somewhat complex, but a good one. We must have many invert together so that your IQ can be tested. You can have much complex circuits in future. Okay, any doubts on this? Okay, we'll move to the another two circuits left out. We'll finish in half an hour or 40 minutes. Okay. Okay, we'll jump to the first LCD because you are getting. Okay. Now go to the new. Create new, and then we'll go to the LCD. Because we will enjoy this LCD. Okay, LCD 16:2 connection I am planning now. Now I'll keep this here. Now I need a small breadboard so that I can have all easy to handle. Big breadboard will take much bigger space. Where is a breadboard? Okay, LCD also take. Now take the breadboard, small breadboard. Yeah, mini breadboard I will take. Now this I will rotate. So that connection will be easy. Now I will explain LCD now. LCD pins. In detail, I'm not going on the rough manner. I will explain. So from left side to the right side, we have 16 pin. That is, first one we will give to the ground, VCC, that is 5 volts, and VD, or that is called contrast. Means the display contrast, light, bright, are not visible. That contrast, it is given here. Okay, there is contrast, and this will come from the potentiometer. By changing the resistance, the contrast can be changed. That is like display light. In your mobile also you will have the brightness adjustment. That is called brightness adjustment. Now reads select register select this is, and this is given from the uh, 5 volts, and this is read write. This will give to the what we called ground, and enable, and this is given from the output from the Arduino. And we have data pins from 0 to 7, db1 to db7. Among these 8, any 4 you can take, or generally we will take from 7, 6, 5, 4. These 4 pins will take to display something on the LCD. Remember, no need of connecting all 8 data pins. You can connect 7, 6, 5, 4 or 3, 2, 1, 0, up to you, no problem. In the program you have to write those pins you used, that's it. Now remaining 2, this is LED backlight. This is backlight, that is this is power supply, and this is LED, and this power supply is given with the resistance, so that the backlight, we have 2 things. One is contrast, that is brightness, and another thing is backlight, means light from the back inside the LCD. So for that, these 2 connections are there: LED backlight, LED anode, and LED cathode. Plus and minus 5 volts will give here with resistance. Now here LED cathode will give directly negative, that is negative supply. And starting 2 also 0, first and second, ground and VCC will give, that is ground and 5 volts. The third pin will give for the contrast, which is given from the potentiometer, so that if you vary the potentiometer, the resistance, potentiometer is nothing but resistance, the brightness of the LED will change. And remaining 3 pins what we have are register select, that we will give to the power supply, and read write will give to the ground, and enable means we have to enable the LCD, that something has to be right or not, means we are writing enable or not enable, means if it is 1, it will start displaying something by from the data pins, or the data pins will get the input to the LCD, and they will print it. If it is enable is 0, it will not display it. So like that it is. Very simple explanation. It is not much worse. Don't worry. It is a 16 pin. How to remember? It's very easy. It's not a big deal. Now we'll come to connections. First we'll connect it. Now first I will connect 5 volts, so that easily you can get. I will connect this 5 volts in one place. Red and ground. Because these are vertical pins are shorted. Be careful. These vertically, these are shorted. Okay, now we need a potentiometer. Basic. Yes, we'll connect this potentiometer for, I told you this is for brightness adjustment, contrast. So first and last will get directly to get the supply to the potentiometer. This is black because this is red because supply. Now, where do we have to give this potentiometer connection? We have to give this potentiometer connection to the brightness. That is called third pin. I can have some any color because the brightness. Now take this is red supply. Now ground. Ground I will take from here. Black, no red, no black. Okay, next I will have another thing. Red, black. Now main things will finish. We'll have resistance. I'll rotate this. You can have resistance 150 ohms. Later we'll decide how much brightness we need. Okay, this is from the red. Now this is going to LED anode. This is red. Now coming to the black, that is called ground. I'll take from here. All wires colors are different, so don't worry. Ground mainly. Now I can start just simulation because here I want to show. So it is broken. Why? Because we didn't this. We have to have 10 kilo ohms. Now resistance also we need 1 kilo ohm. Let's check. Start simulation. Yes, now it's working. Now see, this is the brightness. See, you can see that inside boxes, 16 boxes. You can see 1, 2, 3, 4, 5, all are 16 boxes, one row, and 16 boxes, second row. That's why it is called 16 by 2, means 16 digits with 2 rows, right? 16 columns with 2 rows, we can say also. So this is finish. Okay, backlight is coming and we can adjust the contrast. Now we have to connect data pins and register enable that one. Now okay, now we'll connect what we call read write to the ground. Or we can have ground directly from other place because here no room. We have ground from here. Black. Okay, now RS from pin number 12 we can have register select. Okay, one green pin. Now enable can be from pin number 11. Some other color we will take orange so that it will be easy for you to understand. Okay, only remaining these 4 pins. So now I will connect, or I will move this here so that no, not possible. Okay, I will connect these 4 pins. This one to 5. D7 I will connect to 5. Anyone you can take, no problem. That is not a big deal. Check colors from here. Okay, beside 4, not blue, pink. Three, purple. That's why we are using different colors so that you will not get confused. Pink is more brown. Connections are over. Yes. Keep it aside. Okay, now coming to the code. I'll remove this, but here the problem is LCD doesn't have block. That's a drawback I will tell. Now we'll go for the code. So just to take the text, so we'll go for the code. Now I have to type something one by one. I will type here. So there is a library on LCD. Include #include less than this is your #include liquid crystal.h library, from where you will get the LCD output, LCD program you will get. Now I have one function liquid. We have to give the pins to that program where we connected. Space LCD. This function will tell where the pins are connected. 12th pin is connected to the register select. 11th pin is connected to the enable, and we have connected 2, 3, 4, 5 pins to the data pins. So this is about the pin. 12 is register select, 11 is enable. Here register select and enable. Read write is given to the ground. Next we will give the 2, 3, 4, 5 pins to from lower to higher. D 4th data pin, 5th data pin, 6th data pin, 7th data pin, like that. Now in void setup, just will display what we are printing. Serial dot begin. We are to giving the enable serial begin. This is for serial monitor. What exactly you are printing on the LCD, we will see in the serial monitor. So that's why we have to start the serial monitor so that it will be easy to understand. Okay, now in void loop, we will start coding LCD dot begin. This is, you have to start the LCD every time. How many characters it has? 16 characters with 2 rows. That is called 16 columns, 2 rows. You have to start the LCD. Now again LCD dot, we have to set the cursor. If we are not setting the cursor, it will not be start from the 0 point. It somewhere it will start. It will be difficult to us to control. set cursor at 0, comma 0. What it means? It is 0 row and 0 column. That is from the first digit. This is the column. First value here it is column and second value is a row. So 0 means 1, the first one. So first digit nothing but 0th row and 0th column. 0 column, 0 row. That it means. First one is column, the second one is row. So 0 means the first digit. So the cursor we set there. So what we are printing there? LCD print. In the LCD we are printing LCD dot print. I print Assalamu alaikum. It should be in double quotes. Assalamu alaikum. Whatever in the double quotes, it will print on the LCD. Now, this is in the first line, that is 0, 0. Now, in the second line, what I will print? LCD. For that, we have to set the cursor. LCD set cursor. At 0 column and first row means that here it is second. It means 0 means first and 1 is second. So it because it is a digital, na? 0, 1, 2, 3 like this will go. Okay, now here what we are to printing? LCD dot print. I will type students of KKU so that no, there is a problem because I have to use double quote. Okay, this is okay. Now the same thing I want to show what I am printing in the LCD. I want to show in the serial monitor. We will see. For that, there is a code serial dot print, because previously it was LCD dot print, means it is printing in the LCD. Now it is serial monitor, means serial print. It is serial dot print ln, means new line. Every time in the new line, print is okay. Ln means new line ln. So what I am printing? Here, no need of the two statements, putting the cursor in the second line, in the first line. It is direct printing it is. No, it's not correct. No, I will close this. Okay. Now we had some delay, otherwise continuous running it's not good. So 1000 we have to use because program accepts with milliseconds, not the second. Now for every loop, the LCD should be clear. So we have to erase the LCD. So for that, LCD dot clear. All these programs are available in the hash include liquid crystal dot h. When we include this library, the program which have calling the function, when we call this function, this will go to the inside the program of this file. When you call LCD begin, it will go to the program of this file and it will generate, it will do some action. Okay. So this program is finished. Now open the LCD here, serial monitor, sorry. Now start simulation. See, Assalamu alaikum, students of KQ. For every second, 1 second, it is printing. Now, if you want to increase the delay, you can increase the delay. Stop simulation. You can have 2 seconds so that you can understand the LCD delay. So it is printing step by step. Now here you see, you want to check the potentiometer. Yes, the brightness control. I am decreasing the brightness and I am increasing the brightness. It is showing. Now same thing, if we change the value here, and you see, if you increase the resistance, the backlight brightness is decreasing. Backlight is decreasing. See, further, backlight is decreasing. So 1 kilo ohm is okay. Now let us take 500 ohms. If I set, what is happening? Oh, it's also good. If I get for 400, No, 400 is also good. 300, 300, good. If I get 100 is, it is 150. No, 200, up to 200 is okay. 200 with full brightness. The backlight is full. Now if I change the potentiometer, we can have optimal now, because brightness and backlight should go together to get the exact intensity of the LCD, right? You can see in the mobiles also, same thing it is. Backlight, if you are in the power saving mode, the backlight decreases in power saving mode. And if you increase the brightness, it will also decrease the visibility. So these are the two factors which affect the visibility of the any display. So this is very important. What I typed, Assalamu alaikum, students of KQ, and this Assalamu alaikum, this A, I put in the first column and first row. That's called 0, 0. If I want to put first column, second row, then we have to put set cursor 0, comma 1. 0, comma 1 means first column, second row. That is here, the student. Yes. Now, if you want here, it is called 0th column and 0th row. That is first column, first row. As per in our terminology, in programming terminology, it is 0th column and 0th row. It is 0th column and first row. So like that. But in serial print, there is no problem. Directly where whatever you type here, it will print. No need of new line, no need of set the cursor in some place, not like that. Okay, so this is the delay. Okay, let's have last one so that it will be easy to you. What I finished, LCD display finished. Now last one, temperature sensor connection and programming I will finish. Or we will have temperature sensor with LCD connection. Okay, so that it will include all. Easy it is. Okay, so same I can use. We can copy this so that it will save the time. Within 15 minutes or 20 minutes it will finish. We'll copy this one because same LCD we am using, only temperature sensor I have to connect and you have to program it. So I am duplicating it. Now Control V, temperature sensor with LCD. Okay. Okay, get ready for this. Bear with me another. Yeah, here I have to connect only the temperature sensor. What is that? Here I will take this temperature sensor. I will connect here so that it will be easy to understand. Okay, 5-volt supply. I will take this 5 volts. Here I have 5-volt supply because this is red, this is ground. I can have extra ground. Yeah, I have extra ground. I can use this. Black. Now only one connection left, that is V out. Where we have to connect this V out? Can anyone? Sorry, wrong. I have to connect this V out to as a input. V out should be connected as a input to the Arduino A0. Arduino A0. This should be orange. Anything white? Oh, not visible. White is not good. Gray one, everything is over. Yellow, no problem. Okay. Temperature sensor is connected. So everything is connected now. You have to go for the code now. So I need some equations. That is, I have to write in the void setup, you have to write pin mode because they are connecting the data temperature as an input. So pin mode, I will take TMP temperature comma input, or you can take the A0 also, but it is not correct. So because the temperature is there, I have to initialize this temperature. Int TMP equal to A0, pin A0, right? This I initialize. Why I am putting, that's why separately I am running. Pin mode temperature should be input. This temperature is nothing but A0 pin. Now coming to the main program, I will have another one, float some value. Okay, so I am declaring some variable value which is in float. What is a float? Means it is with decimals. It is called float. Integer means only numbers without any decimals. Now LCD is same, no change, because here temperature we need some calculations. So for that, need float some voltage. I'll take some as a variable. Anywhere you can declare the variables here. There's a good one in the programming of Arduino. Analog read TMP temperature I am reading, no problem. It should be multiplied by 5. I'll explain why it is, no problem. Next, then again voltage I am setting divided by equal to 1024. Okay, I will explain that part. Again I will take float variable called temperature. Be careful, the spelling is very important. If you take big one, this way spelling is very important. Temperature C, which is equal to voltage minus 0.5 into 100. I will explain, no problem. Voltage minus, okay. Now LCD begin, you can have set cursors at 0, 0, no problem. You can have here LCD print, will print in the first line temperature is. We'll print this one. Now set LCD 0, 1. Now LCD here temperature. After that another LCD we need, because we have to print the value of the temperature. LCD print in brackets. If it is not in the double quotes, it will give the value in that variable. Temperature. Be careful, temperature C, because that is a variable, right? Temperature C, close the bracket and semicolon. Next LCD print LCD dot print. Now I want to print its is in degree centigrade, like that I want to print, so that it has to differentiate. Now LCD print dot print double quote, I print star star, so that I want to have some differentiation. Okay, now same thing, I will print this in serial print, serial dot print, serial monitor I want to print, serial dot print, double quotes, temperature, in with a backslash n. It is called, it is going to the new line. Now serial print, another serial print I need. Oh, there is a problem. Yeah, there is a wrong one. Another serial print, serial dot print. Now we have to print the value of the temperature. Temperature, close the bracket. Okay. Up to here, okay. Delay, everything is okay. Now something is wrong. Yeah. Temperature. Yeah, this, it has to go here. Cut. After this, temperature already printed in the LCD. Now the LCD cursor should be in the next line. Okay. Now I will print this and I will show what is it is going. Okay. Up to here is okay. Now start the program. Any problems, we will check. Yeah. Serial print. Yes, spelling. Serial dot print. Capital T it is. Sorry. Capital T and temperature C. The variable. Okay. Now see here. What's happening? T-U-M-P-A-R-A-T-U-R-E-C. Yes, it's working. Okay, the function void loop. Okay, semicolon. Somewhere we missed the semicolon. Where it is? For this, it is there. For this, for this. Yes, here. Semicolon we missed. Okay. Yeah. See the temperature, it is 24.71 degrees centigrade. This value. Now increase the temperature. It is coming correct. 89 up to 125. We have up to 125 degrees centigrade. Right? So this is the temperature. Now minus. Okay, I will explain the why this is happening. Okay, now here, why is this equations? Why this I multiplied by 5 and why I divided by 1024 and why I negated this. This is data sheet from the temperature sensor company that we have to first multiply and divide with 5 volts, because whatever the output we are giving to A0, it is because the temperature sensor is getting 5 volt supply, so it will give the output with 5 volt supply only, but it has to give in terms of bits, 8 bit. So convert this 5 volts to 8 bit is nothing but 5 divided by 1024. You clearly it is mentioned here, we are multiplying by 5 and dividing it 1024, so it is called scaling. It is no, it's not scaling, it's converting, because converting to the milli volts to the bits value. Now the voltage what we are giving is not exact based upon the temperature sensor company data sheet, what the company manufacturer they will give. Based upon that, it is minus 0.5 volts, because it is 5. Generally they think that 5.5 volts the voltage it is given from the Arduino or from other supply. So by default we have to minus this 0.5. Now multiplied by 100, because it is in millivolts we are converting to, sorry, because it is in volts we are converting this float value to with 100. So that's where this equation given from the data sheet of the temperature sensor of the company who manufactures the temperature sensor. So we are getting from their equation. Okay, now LCD begins 16 and 2 is the 16 uh, is the digits of the each row, and 2 is the number of rows. 2 rows we have. Now LCD set cursor 00 means starting position of the LCD. Now we are printing temperature. That's it. Now we are setting the LCD cursor to the second row, first digit. Now there we are printing temperature, means value of the temperature, whatever place, whatever we calculated, that it will print. Now in LCD print C, because beside that value we are placing a unit. We have to place degree centigrade, but there is no such uppercase letter printing facility in the coding, so we are placing capital C. Now I am placing with some space and stars are after this C. Why I will come in 1 minute. Now serial print temperature. Now I am printing this here in serial print. See, temperature we are printing every time. Now we are printing the temperature. Now come to the this, delete this. Okay, now after this serial print and degrees centigrade, again serial, I will convert this into degree Fahrenheit also, that I am typing over 4 lines, then we will finish the today's task. Serial print, this is degree centigrade, you close this one, this is finished. Now I have to use another variable, float temperature F, that is called degree Fahrenheit, which I can give equal to, in brackets, temperature C, temperature capital C multiplied by 1.8. This 1.8 is coming from 9 by 5. What is the equation from temperature degree centigrade to degree Fahrenheit? It is nothing but degree centigrade multiplied by 9 by 5 plus 32. So 9 by 5 is nothing but 1.8. Okay, so that from there I will got it. Now this is the equation for conversion of degree Fahrenheit, degree centigrade to degree Fahrenheit. Now same we have to copy LCD print and F and everything. Okay, LCD print now. LCD dot print. You have to print here only the temperature. No need of heading. Temperature F. Close this semicolon. Again, we turn to print the units. LCD dot print in quotes. LCD we are printing. Okay, that's why it is coming here in quotes. Okay. Okay, now same thing we will print in serial print. Serial dot print, because I want some space, that's why I put star star. I put this and I close this and this. Okay, serial dot print, I am printing now the value temperature F. Yes. Now we have delay. Okay, this is finished. Now see the output. Maybe some problems. Alhamdulillah. See, I am printing temperature in degree centigrade and degree Fahrenheit. See here the error. This is not C. This should be F. In LCD print, it should be F. And here also I have serial print. serial dot print. I have to print f and \n. Okay. So that in serial print also I must have same thing. Okay. Okay. Temperature. Why temperature? Yeah, now it's coming. Temperature 24.7 degrees, 24.71 degrees centigrade, and 76.47 degree Fahrenheit. Successfully, we are printing the temperature value. Now change the temperature. It will change it. See, now change here minus. Everything is here showing. So like this, we have to enjoy the programming, block building, everything we can do in the Tinkercad. Okay, I finished all successfully. If you have any doubts, you can ask now. I'm stopping here. Now another slide I have to show to you. This we finished. Only we didn't finish. We didn't complete temperature sensor connection program. This is also finished. Okay. Okay. Now I'm moving to here. Where is it? Okay. Yeah, feedback.